So I've done a lot of work on TwitchCock off stream. If you guys want to follow along, we can minimize that. We don't need that. GeoHot, TwitchCock, Shirtaj, hello. So my MetaMath verifier, I believe now with my latest edition will pass all the tests. Wait, not okay, what? File not found error. Enums is not defined. All right, well, we have some bugs, so good. Let's fix them first. Some of them I just introduced. TwitchCock. Andrash, I've acknowledged you. Please don't abort the stream. No, I finished that stream up. Don't say I didn't finish a stream. My decompressed proof, yeah, this shouldn't be in MS. This should be V sub MS. Yeah. Not okay, hol.mm. Not all arguments are formatted during string formatting. Yeah, this isn't right. I'm getting out of range errors. Oh, here we go. This is just a CSS. Why am I getting out of range errors? VMS? Oh. I should do this in VScope. Perfect. Okay. That fixes that bug. So this is, if you guys want to play along at home, this is on TwitchCock. I'm editing verify.py. This is the MetaMath verifier that I wrote last stream. I've cleaned it up. It was at one point passing all the tests. So MetaMath has a little test suite, and we're just passing them all. But test simple file inclusion, empty file. Okay, here, there's a bug in this one. iset.mm. This is just resync iset.mm. No such file directory dot. Oh. It's in a comment. Okay, so I thought I was clever, and I wrote a preprocessor. So basically, you have to deal with includes. You have to deal with includes, and the problem is includes can exist inside a comment. All right, let's watch me write a regex for an hour. Regex. I'm so bad at regex. Who's good at regex? Yo, don't tell me I should stream more. Don't tell me what I should do. This is what I did instead of a regex because I don't really know how to write regexes. I'm sorry. I know you guys like when I make it big, but it's not going to be big because it's hard for me to use. File not found. No such file. ... shouldn't even be the file name. See, this is frustrating. The other alternative. All right. I think we can do it not in the preprocessor. I'm a little bit careful about how I write it. We'll add it to the grammar. All right, so here's the grammar. It's called an include statement. File name. What? I don't know. Say char plus. Call it a math symbol because it's lexed. I learned about lexers and parsers this morning. That's what I was playing with this morning. Include statement. Alright, so this crap doesn't work. Back to here. No. Yo, I know what song we're gonna listen to.
Genetic engineered sickness spread amongst me. My people are so hungry that they attack without reason, like a fucking dog ripping off the hand that feeds him. Immortal technique is treason to the Patriot Act. So come and get me, motherfucker, cause I'm not coming back. This is the point from which I can never return. And if I back down now, then forever I burn. This is the point from which I can never retreat. Cause if I turn back now, there can never be peace. This is the point from which I will die and succeed, live in the struggle. I know I'm alive when I bleed. From now on, it can never be the same as before. Cause the place that I'm from doesn't exist anymore. This is the point of no return, nigga. You better believe this. Mary Magdalene giving birth to the children of Jesus. The evolution of the world, bloody and dramatic. Human beings killing monkeys to conquer the planet. The kingdoms of Africa and Mesopotamia. Machine gun in your body with depleted uranium. This is the age of microchips and titanium. The dark side of the moon in contact with aliens. I started out like Australians, criminal minded, broke into hell, tore it down and built a city behind it. Southpaw, murderous methodology, nigga. Remember that I'm just a man, don't follow me, nigga. Cause once you pass the point, you can never go home. You gotta face the possibility of dying alone. So tell me, motherfucker, how could you die for the throne when you don't even got the fucking heart to die for your own? It rains acid, one day the earth will fry from a stone, and you'll be looking at the world living inside of a dome. Computerized humanity living inside of a clone. This is the place where the unknown is living and real. Wormwood, the planet X, and the seventh seal. Universal truth is not measured in mass appeal. This is the last time that I kneel and pray to the sky, cause almost everything that I was ever told was a lie. This is the point from which I can never return, and if I back down now, then forever I burn. This is the point from which I can never retreat, cause if I turn back now, there can never be peace. This is the point from which I will die and succeed, live in the struggle. I know I'm alive when I bleed. From now on, it can never be the same as before, cause the place that I'm from doesn't exist anymore.
All right, we fixed final inclusion in the length of the song. Now we can get to 2 + 2 = 4. So I wrote a REPL for MetaMath. So I've preloaded the piano arithmetic. Actually, I should, now that my including works, be able to preload 2 + 2. Perfect. Who cares about Unity, guys? So check this out. Like, that's a proof. So when you look at MetaMath, if you read the old diffs to this, you'll see that this function here, instead of verify proof, I now call it exec MetaMath. So the proof is really cool. The proof is just an assertion statement with this added part onto it, right? An assertion is just an axiom. You can write anything you want there. In order for something to be a proof, it's the same start as the axiom, but instead of the axiom just being taken for granted, you have to describe how to reach that axiom with a proof. So I can add in, so I'm going to load in piano arithmetic, and I can start with something like 0. And I can say, 0 is just an axiom, right? Now, what does it mean for 0 to be an axiom? And this is where MetaMath gets really trippy. MetaMath doesn't, it's still not exactly clear to me how you prove something in MetaMath. It's just a symbol manipulation language, but I think there's ways to build the proof on top of that, and that's why it's meta. So you'll see that I can do cool things so T0 just pushes 0 to the stack, and then I can do something like T successor. For those that don't know, we're talking about piano arithmetic. So everybody should know piano arithmetic. It's actually really simple. So piano arithmetic is a way to describe the integers in a very clear way. And then these are all the... Wow, this is more axioms than I remember. But remember this. So you start with 0, and then you have the successor to 0, the successor to the successor to 0, and that's 2. So the number 1 can be defined as successor, right, like that. Okay, so now if we want to write the expression 2 + 2 = 4, let's start by pushing 2 2s to the stack. Whoops. Oh, I had a plus. I'm actually going to fix that bug right now. It's kind of annoying to work with. So when we do input, we're going to have to display a strip here. If I have a space after the thing, it doesn't work. Yeah, that's right, because it's complaining now that the stack isn't the right length because I pushed 2 2s to the stack. So let's put bin up plus and t bin up. Okay, so this is 2 plus 2. This is the special code for 2 plus 2. So here's my proof. That's 2 plus 2. And then if we want to actually verify this proof, I think that's how you end a proof. Is that right? Yeah, with that. So, and I'm trying to prove here 2 plus 2 term, this, and then a type term. But this isn't actually a proof of 2 plus 2. This is just a proof that you're capable of expressing 2 plus 2 in the formal system. That's just, it's a valid statement. So you see here it verifies 2 plus 2. Verify 2 plus 2, right? But that's not saying that 2 plus 2, it's just saying that 2 plus 2 is a term. It's not even saying it's a well-formed formula. So if I want to do that, so let's say 2 plus 2 equals 4. We want to say it's a well-formed formula, which means, like again, 2 plus 2 is just a term. It's not a formula. Well-formed formula, 2 plus 2. We're going to push these both, so successor, 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 0. And then we want, oh, actually, this probably I just put an equals here. Now this proof's not going to validate anymore. Because this stuff here isn't what generates that. But I believe, so let's just say you get 4 there. And then it's not bin up, it's like bin pred. Yeah, bin pred equals. And this is a, not t bin up, it's a woof of atom. There we go, good, very nice. All right, so it produces this and it expected that. So this is the statement that I'm trying to prove. And this is the proof for it. It's a stack machine and it uses Polish notation. So first you push the 2, 2, and then the plus, and then execute, push the 4, push the equals, and then you say that it's a well-formed formula. But this isn't actually what we want to prove. We want to show something about turnstile, I believe. So I think in order to prove this, yeah, propositional logic. They break this down. Actually, I haven't read this part of this MetaMath book yet. I do realize that even if I create my own math, I can't prove true equals false. Well, that's actually a lie. I can. Let's just fix that as well. I like being able, what? Huh? I don't understand why that has any length. I don't understand why if I just press enter, it has length. It shouldn't. Oh, I guess because if you split, that's still actually going to have one length string 0. That's cute. Good, now I can press enter, I'm happy. Now, I'm not exactly sure how to actually prove this because it adds... What we're trying to do is prove 2 plus 2 equals 4 in the MetaMath language. And I've written my own MetaMath verifier on a previous stream. So once we write the proof, we can have my verifier, which is well tested, say, does 2 plus 2 equals 4. We're definitely going to have to use this turnstile crap. Implies phi implies phi psi. So WFF stands for well-formed formula. I like vaguely remember all this stuff from way back in the day. Well-formed formula. So, unfortunately, right now, since we're not actually doing anything with the plus, 2 plus 2 equals 3 is also a well-formed formula. Wait, yeah. But it's not. So, I mean, if I just get rid of one of these and get rid of one of these, 2 plus 2 equals 3 is a well-formed formula, but it's not a provable formula. And in order to prove stuff, we're going to have to use the axioms. So let's go to the axioms and maybe we can start from there. The axioms are the only thing that gives the plus symbol any meaning. So we define plus as a constant, we call it bin op plus, but then these are the axioms that say turnstile equals. It's just a type change? Yeah, I guess it's a type change. Okay, that's interesting. I mean, if you have a well-formed formula, right? So I guess you could just make it a type, right? What is this thingy called? What is this thingy called so I can give it a right name? Do you guys know? Turnstile? It's not what I wanted. Math. Yay, here we go. Turnstile, prove. So I think that might actually be correct. These are the usual. Okay. 0 is a natural number. I'm not sure why that's axiom 1. Oh, well, there's an implies there. Yeah, okay, we have to get through how they're defining predicate logic. Right, like to get right to piano arithmetic, Coq does a better job. I mean, I'm not going to say better, but Coq's predicate logic is just, it's more normal. I don't know, maybe this isn't even abnormal and I just don't really know this stuff. I've grown to really like MetaMath though, because you can write the verifier. Like the code that the language that I'm coding in, I wrote the compiler for. Okay. All right, so like you can see this axiom makes sense, right? X times y plus x equals x times y plus 1. Right? X times y plus x equals x times parentheses y plus 1. So that's a very cool thing. I guess, yeah, so these are the two, and they're just showing that they're equal. I don't really know how to get from a well-formed formula to a language. Okay, so this says 0 does not have a successor. Successor of x, successor of y implies x equals y. Unlucky Chicken, thank you for subscribing. Oh, we haven't even written a verifier for MetaMath in MetaMath. You know, I'm sad that this whole the Twitch cock doesn't get more views. Okay. So maybe we will have to understand a bit of propositional logic before we can do this. These give the inductive definition of a well-formed formula. Correct axioms. Here we go, look. No. Follow closely propositional logic defined in set MM. We do have to change the following axioms into Polish. What is modus ponens? This is like a common thing. If P then Q. Okay, yeah. So it's just if P then Q. If P then Q, then if P then Q and P then Q. Oh, that's so cool, man. I love logic. Equality axioms. Who loves equality? All right. Equi successor, equi bin up. Yeah, that looks hard. Hope we don't need to know that. How do I turn, where does this thing come from? They're just axioms of logic, right? So I guess I'm gonna have to derive, the whole thing from, here we go. Okay, let's start by proving something simpler. What are your comments on this again? Oh, it's this. Can we prove 1 not equal to 2? Let's say 1's not equal to 0. Proof not 0, successor 0. So if I wanted to prove that, I just have to construct 0 and Peano arithmetic axiom 1, and that should prove it. No. Let's see what I can do in the rest. I can make a 0. And PAX1. Oh, PAX1. Assertion, scope, V-type. It's not the right type. What do you mean? What's the type of X? How does it know a type from the axiom? So I'm trying to... This should substitute for the variable X. Oh, X is a defined variable somewhere, yeah. X is a var, not a term. So I was trying to make it a term. T-var, maybe? No. T0? T-var. Wait, but T0 is already what I had. And T0 is a term, not a variable. Oh. I understand. So we have to somehow do it for a variable. PAX1. So in PA, in the first axiom here, X is defined up here to be a variable, not a term. Right? Just, I mean, it's not to say that it's a variable, right? It's just to say that X has type var, and I was trying to put in an expression of type term. So that's why T0 PAX1 doesn't actually work. T-var can make a term out of a variable, but I don't see any way to make a variable out of a term. Oh, this is hard stuff, guys. You don't need to be rich to pick up girls. You just need to be strong. Oh, well, that's because the label's not found, but that's because the type's wrong. Eating ice, bro. Well, we haven't really gotten anywhere yet. Bro, yeah, you gotta go to the gym, man. Want to pick up girls? Gotta go to the gym. Okay, so what is a var and where do I get vars? Wait, what? They only exist there? If they don't exist in the axioms, how can I possibly get vars? See, look, all these things produce terms. Nothing produces vars. Oh, I know. I could actually say var x. Yeah, and then if I say like var x and pax1, yeah, that works, but it's useless because I'm just binding x to x. I can put other variables in there, like var y. But I don't know how to actually assign anything to variables. Yeah, there has to be a way to do that, though. Like to say that like x equals 0 for this. Right? Oh, I mean, I guess I can say like var x t var, and then I get a term x. But that's useless. That's not what I want. I want a var 0, but I guess you can't have a var 0. Why do these stupid axioms only apply to variables and not to terms? I actually don't know. There's a chance this is broken. But no, it seems like, let's not assume that yet. This has to just be something I don't understand. It's green because it's a comment. T is a term. All a limb? What? Okay. Huh. Like, I mean, think about that statement, right? Like, it's pretty obviously a true statement. I'm saying that 0 is not equal to 1. 0 is not equal to the successor of 0. But what I need to do effectively is not, I need to specialize the axiom. So I want to show that this is true even when x equals 0. Functions are terms. Are they? Those things are terms. Those things are terms. No, I think just those things are terms. Zero is a term. Is that a typo? I was trying before to get MetaMath to sort a list, and that, I don't know about that. And then I realized that we first needed to make numbers, and now we're here, and we're trying to prove that 2 + 2 = 4. And this is like trying to prove that false is not true. These things are really hard, guys. All right, so like I can bind y. Look, see, look, it's true for y as well as x. But I don't know how to get to terms. I'm substituting a term for the free occurrence of a variable. So let phi be a formula, x be a variable, and t be a term. Ah. For all x phi, for all x implies x equals t. We're programming in MetaMath, guys. And we have to figure out how to get 0 in there. We got to figure out how to turn variables into terms. And I guess, actually, we're searching for the wrong thing because these things are all defined as variables in terms. So anywhere they use t, it's fine. Or s. These seem to be true things about terms. Guys, I think we can prove that 0 equals 0. Watch this. We're going to prove 0 equals 0. T0, equal. Yeah, oh, that's a good, oh man. Watch this, we can prove that 1 equals 1. Yeah. Now to prove 0 is not equal to 1, that's really hard. No. We're using Peano's axioms. I didn't write any of this. I just copied this library out of MetaMath. Yo, we proved some stuff. We proved 0 equals 0 and 1 equals 1. Now, how do we prove 1's not equal to 0? That's going to be hard. The problem is that has variables in the name. We're going to need some of this stuff. What are phis and chis? Oh, they're well-formed formulas. Oh. Okay, if we want to prove that, we have, t var x and that, or, oh, I should make tab complete work. It's not a t var x, it's just var x, okay. So we have that, we just need to, instead of x, we need to replace x with a bound 0. there actually should just be a function for this. We just need to find it. Like T0 question mark. Man, I should actually be able to make it question mark and it should be able to search for it. Real MetaMath might actually be able to do that. Yo, you know what we're gonna be able to do soon? Why don't I just try them all? Why don't we just use search? Like we could just try every, put every label in there. We'll get there later. Let's just understand it. Before we try to cheat, let's just understand it. All a limb. It might have to do with these all a limb craps. Implies. Like, I think this is called, like it's, I think of the term template specialization, but that's actually a C++. How about prove it on paper first? No, I don't think it's modus ponens, and like, it's not really like, this isn't really a proof, right? I have the axiom. We're not even up to 2 plus 2 yet. We're still trying to prove that 0 is not equal to 1. So I have this axiom, which says 0 is not equal to the successor of any number. And any number can be 0. And if I just could specialize the axiom on the number 0, that would work. So exists x phi. Yeah, no, it's not. What's the type of this? So that, which is a phi or no? No, phi's a well-formed formula, it's not that. So maybe we're not up to that yet. Maybe what we first actually need to produce is this. Ah, okay. And then we specialize it using one of these guys. Yeah, that probably seems right. Okay, so this is a well-formed formula, so let's produce it. T0, T-suck, T0, binpred equals WFF atom. Not exactly what I wanted to produce. T0 here. Yeah, And now let's get not in here. And I could just say WFF not. Perfect. Okay, so that's the formula. Now, I need one of those. There's going to be something that takes in that formula, that takes in x, that takes in 0, and that takes in the axiom, and makes me the true statement I want. These things are all about terms. It's so annoying. This notation that it's written in is kind of... No, maybe not. I don't know what quant means. For all x, for all y, that's two values here. So all a limb. It's this. It's got to be this. So let's just go here. You know what? We'll leave that. I might not need that. Implies... No, phi is the well-formed formula, so I do need that. So that's phi. X is var x. And the term is t0. All a limb. Now, because the binding's in the wrong order. All right, it's something. Implies for all x. Now I need to do some shit with the implies in order to generate. Remember, we're trying to generate this statement here. So forget the type of it. We're just trying to say this. Implies equals x 0. See, so what we want to do now is take we want to use the we got to use the axiom somehow. But implies, I wish they'd write some damn parentheses for this stuff. Is there any way I could generate parentheses? I don't know. For all x not x equals 0. Yeah. It's kind of what I want. Maybe all lim isn't what I want. Look at all in 3. Implies for all x implies yeah. The formula phi t for all x implies, yeah. For all x implies x equals t. Maybe I'm just not really understanding implies. Why is it a log bin op? What is a log bin op anyway? Implies phi implies okay. It's a lot of implies. It would definitely help if there was parentheses. We're trying to prove that 2 plus 2 equals 4. All right. Maybe I have to say var x here. That's not true anymore. Oh, and then tvar? Yeah. But okay, so basically, if I know for all x that Georgia set cannot contain itself. What? What are you yelling about? We can definitely say x equals 0. If I know x equals 0, how do I substitute? I don't even know what quant means. Okay. So I think they're writing this here with the parentheses nicely for me. So for all x phi, we can just write this. So we can say for all x, phi implies for all x. This is like what it looks like in cock, right? So this all lim for all x phi, which is an expression containing x, implies for all x such that x equals t implies phi. Okay. So I guess the only thing, all right. So this is very nice, right? I love the internet too, Snake AZ. The internet. Okay, Amritesh, you're starting to annoy me. Yeah, no, I mean, the internet's dropped all excuses. You can be whoever you want to be now. Like, it used to be things were gating you based on access, like whether Harvard accepted you or not, if you wanted to learn about economics. But today, just go watch YouTube, man. You'll learn more than most Harvard students. If you're, like, diligent about it for a while. For all x phi implies for all x, if x equals t, then phi. Yeah, see, this is kind of what I want to use. We apply it to phi and get that MetaMath proves. Wait, sad to say Geo couldn't deliver his comma systems? Okay, first off, that's wrong. And second off, we don't talk about comma here. Get the fuck out of my channel. Yeah, we can raise the font size a bit. That's what you got. All right. We're gonna get this. This completes our discussion of for all elimination. This is the whole hard part here. Well, so, like, we have the axiom, and that's clearly true for all x, but I don't really see the for all. Quad all. Zoki, Macola, we don't talk about self-driving here. This is a math channel where we talk about math. We do math on channel. What's alpha equivalence? Oh, 12. Oh, I heard about this stuff once. You know, a friend and I were talking yesterday, and we were realizing that crypto is where all the scumbags went. No. Amitesh, we don't talk about Comma AI at all, and you may go down in history as the first subscriber to get banned. What happens when you ban a subscriber? Banning subscriber on Twitch. Yeah, okay. So we're gonna have to construct for both this is a construction and this is a construction, var x t var. And then this is what we want to show. So then we gotta do some modus ponens shit. Wow, okay, we're still trying to prove that 1 is not equal to 0. Final case is when the principal connective of psi is a propositional connective. Wait, huh? Yo. It took me like a month. Not a month, it took me like a week to prove that any number times 2 was even, or something like that. Implies phi imply. You need to specialize, like. All right. Wow, that's a hard proof of 2 + 2 = 4, but they didn't use the Peano arithmetic. They used the other stuff. What do I need help with? So we're trying to figure out how in MetaMath to we're trying to prove this statement. We have it as an axiom, except in the axiom, instead of this 0, there's an x. So I'm a little bit confused how the axiom doesn't say for all. But I guess for all is kind of implied by the variable. Here. Well, then we discuss the induction scheme. So, I mean, yeah, we know what induction is. We shouldn't have to use any induction for this. You know, no, see, like, I want to say, like, okay, we're going to prove that 2 + 2 = 4. But the only things that reference plus are the axioms. So we have to figure out how to night mode my search results. How? That sounds too hard. Okay, so this is a distinct rule that x and t must be distinct. So I can't put x in my term. But x can just be var x. The only thing, I guess the term then can't be t var tx. I think this all lim is correct. So for all x, or all x phi implies for all x equals t implies phi. And phi is a well-formed formula. Yeah, so this is like just the type up here. Well-formed formula quant for all x. So I can make the for all x. It just describes how to make formulas. That's kind of useless. I mean, yeah, we could get the MetaMath searcher to find this for us. But this is just me not. This is frustrating. I don't really understand if this is right. I don't know what a principal connective is. Maybe we have to read this to really understand. Axioms and inference rules of predicate logic. Prove the rule of inference and the axiom associated with the for all quantifier. And phi does not contain x free. Alpha equivalent formula. All right, and then we have if, then we can use modus ponens, which is if P then Q and P then Q. We'll get there. Yo, we got some low quality chat in the stream today. No bound variable phi appears in T. Alpha equivalent to. So maybe it is just this alpha stuff. This would be easier if it was just alpha stuff. I understand it up to this point. Phi is a finite sequence of symbols. designator for a sequence of symbols that either is a term. Implies phi if what? All right, Amritesh, I'm gonna look up Russell's paradox, and you know what? If you turn out to be right, that this is the problem, then you're not banned. If you turn out to be wrong, well, then you're banned. All right. So Russell's paradox says that you try to construct the set of all sets that are not members of themselves, and then the paradox is that if that set contains itself, then it doesn't belong in the set, so you remove it, but then it does not contain itself, so it belongs in the set. That has absolutely nothing to do with this, which is alpha substitution, probably, or something similar to that. Or binding, or these are some terms from prepositional logic that I just don't know. It has absolutely nothing to do with Russell's paradox, and I can't believe that I fell for your strategy of just saying something 5 times. See, this is how much you get as a subscriber. All right, go on, defend yourself. I take a set of 0. Yeah, sure. See, this is how much of my time you get as a subscriber. It cannot contain a set 0, 1. No. You're missing the point. You're in the wrong. We're not using set theory. There's no set theory here. There's only the Peano arithmetic axioms, right? So maybe if you want to redefine math, but I can then redefine math. I can start with whatever theories I want. And I can say that 0 does equal 1. And wait, it sure as hell doesn't take a set 0. It cannot contain a set 0, what the hell does that even mean? Now, you know what? It's funny. It's funny. We're all having a good time here. Just stop saying dumb shit. Wilkins, that's a good proof right there. He's got it. I searched all inside the 1. I zoomed in on that. Picture of 1. Oh, yeah. Yeah, I got a 1. I zoomed in on that shit. Zoom. Zoom. Where's the 0? Oh, I don't see it. Oh, that's good. You're just math. All right, good math. No, like they're getting at what I want to do here. For all elimination. To state it, we now introduce the familiar notion for substituting a term, 0, for a free occurrence of a variable x. So let phi be a formula, x a variable, and t a term. By phi tx, we mean the formula. Yeah, this is exactly what I want to do. It asks me about iMovie all the time. We say that t is substitutable for x as a free occurrence of x if no variable, presuming this notion known. Okay, implies for all x phi tx. Our next step is to show that it suffices to prove the following special case of the axioms. The variable x does not appear in the term t. No bound variable of phi appears in t. The variable x does not appear bound in phi. Hence, MetaMath can prove the equivalence of star we shall need a preliminary result. Are these for all limbs actually used anywhere? I don't think we actually need any of these other weirder ones. I'm pretty sure we can just use that, but we have to figure out how to use it. This stuff, oh, you missed the deep learning times. No, we only do math. This is a math stream now. I did do some deep learning last night, though, or 2 nights ago. If you want to check out AI notebooks, I wrote a variational autoencoder. We apply it to phi and get that MetaMath proofs. Wow, it's really hard to prove things. Propositional calculus. Wow, the axiom of choice. Look at that. Okay, propositional calculus, predicate calculus. Ah, this is where things got crazy. Predicate calculus. Yeah, see, this is weird. By carefully crafting the axioms as to avoid them, building on Tarski's system S2. Disjoint variable. Oh, this is why they need that stupid disjoint variable restriction. I had to implement that. Tarski's axiom of existence, which we label as section 3.3 shows these axioms. Not the propositional calculus. Here we go. These are all straightforward. This is like, you know, if X implies if Y then X, right? So you could from that in reverse. Distributive property, the contrapositive, modus ponens. Those things I know. These ones I don't really know. Axiom of generalization. Oh, whoa. Okay, that's cool. That's the one we can use, but I don't have that. Remember how I was saying, how do we get the for all into the... Yeah, this stuff. I was asking how to get the for all into the axiom. Right, so I think now we can get the for all into the axiom at least. Using one of these alpha shits. Oh, well. Yeah, all right, let's see if we can use alpha 2 to get for all x from the axiom. No, but phi and chi aren't even... Urgh. Wow, okay. We're not even close to 2 + 2 = 4. That's really hard to prove, guys. Bertrand Russell had it right. It took like, 200 pages of Principia Mathematica. Types. All right, let's get some more tea. This is hard, guys. I thought this was going to be easy. I was like, oh, there's going to be a quick stream today. Oh, we're just going to prove 2 + 2 = 4, and like, oh, I'm good at math. But nope, here we are, 2 hours into it, and we haven't even proven that 1 is not equal to 0. And if we don't know that, that's an axiom practically. Yeah, we're using piano arithmetic. And 12? Whoa, Matthew Merman. How's it going, man? You told me about 12, actually. So let's see what's going on here. Yeah, of course, because you have like NAT and shit. See, the magic of MetaMath. I mean, I could do this in Coq very quickly as well. But the magic of MetaMath is... Actually, no, you're not even... No. This is... You're actually just defining it all. So this is not... NAT is nothing special. NAT's just a normal type. Oh, I don't know about modes and worlds. Yeah. The problem in MetaMath is like doing obvious things is just so hard. Yeah, no, you define it all. Yeah. We can do it. Let's do it. You want to do this in Coq quickly? Just as a fun aside? Oh, I should be able to do this pretty quickly in Coq. So, okay, I can define a NAT like this. And then we want to show theorem. 2 plus 2 is 4. We want to say... Not even a for all. Just suck, 0. And then in order to define equality, we can just define equality like that. Oh, we're gonna have to define plus. Math logic at CMU was like MetaMath. Yeah, MetaMath's really cool. I think I can do this quickly in Coq. How do I define plus? How do you define it? Yeah, so I mean, sure. Definition. Plus xy nat yeah, plus nat equals this stuff's, for some reason, this stuff's just so hard to keep in your head. Plus of, well, so I shouldn't define x and y to be arbitrary. Oh no, I can just say here that it's equal to, no, not exactly right. Yeah, I really want to do what you did there. Like successor of x, like there. I might be able to define it as an inductive. Oh, first prove 0 is not equal to 1. Good point. So we want to prove that 0 is not equal to 1. So we can do this by saying is not built in. What is built in? It's a prop, so we want to say that equality of 0 implies, yeah, okay, you're right, good point. We'll do this one first. 1 not equal to 0. Implies false. So we want to do intros. What? Show. This should be a lot easier in Coq now. No, we want to do. Never mind. I thought this was easy, and now I forget exactly how to do this, but inversion. Inversion H. Yeah, that's it. Yeah, so inversion just shows like that they can't be constructed from the same. See, that's the whole proof in Coq. And now we'll define plus. We'll do it in a minute. But see, like, the thing is, Coq has very powerful tools like inversion. It's a little unfair. All right, let's prove 2 plus 2 equals 4. Successor, 0. Plus. You know what? I'm getting rid of this suck. Can I name it this? Is that allowed in Coq? No, you can't have that. Z. Yeah, alright, so I'm done with this. We're just gonna say term S has type nat. And it's expected to have type what? Oh, I don't know. Yeah, oh, I know why, because I didn't define plus. It's using some weird definition of plus. Plus is not a theorem. Plus is a definition. How do I define plus? I mean, maybe do it with a match? Yeah, no, we can do it with a match, like this one. Yeah, no, this is right. Hang on, I'll define this real quick. Makes a nat match X with, and now we need both inductive constructors for nat, Z, and Z, anything plus 0 is just Y, and then we can match it with successor of Z, and that's gonna just be, well, no, we shouldn't, yeah, no, it's gonna be, no, okay, fixed point plus. Yeah, that's right. Well, we'll see if it requires me to write that. But the successor of Z is just either match with that or match with that, which is going to be the successor of plus x, y. I don't like how that rebinds, though. That's not right, is it? Whatever, we'll see if that's right. The reference X is not found in the current environment. No, they find the variables up there. Is that all right? It's definitely right. Oh. Term x0 has type nat. Fixed point. You know what? The problem is this. There already is something in Coq to find this plus, so we'll just do that. And then this has to be a fixed point, which allows you to use the name of the definition in the thing. The term S has type nat goes to nat. Well, it's expected to have type nat. This not. See, and maybe this shouldn't actually be X, and I'm a little thrown away here. We're just gonna. I shouldn't call it 0 like that. So then I can use. We're not actually gonna use 0. Just use W. If it plus W, there we go. Even Z was not found in the current environment. Ah, just these Z's. Making capital Z's. Have issue that code equality check. No, I just proved it. Term S has type. I am finding naturals, the low instantiation reduction, not the higher order abstractions. I mean, yeah, like this stuff has things built into code. Isn't something you can prove things about. I think you can. Oh, we should actually also be able to say compute. Do that, right? Do compute. I'll print. What is it? Eval? What is compute? Does not like that. Syntax highlighter doesn't work. Now the term S has type nat goes to nat when expected to have type of nat. Well, this is Coq now. I don't got this. can't I say SZ here? Oh, is this wrong? No. That's fine. For some reason, if I put it here, it breaks. Oh. Yeah. It's just how it's binding. So stupid. Was 12th that stupid? Yes, it was that stupid too. I've looked at Agda. I don't know. I found it less easy to understand. Okay. Let's prove 2 + 2 = 4. So show intros, show. I can't do it with intros. Like, we're gonna have to get it to apply Equian Raffle. Oh, that was literally all I had to do, and it automatically simplifies it. So, like, that's kind of cheating, but because it just follows so easily from how I defined plus, like, that already verifies. So that's the same proof in Coq. But it's unfair. Like, it's unfair that it has just really powerful tools. And it doesn't have the same crappy axioms. It has like a powerful typing system. It's a lot harder to understand how automated theory of verifiers actually work and how to prove things with them. You mean then how to prove things with them? Proof in Coq, so easy. All right, now let's try to prove those same things in MetaMath. We haven't given up yet. We haven't given up. These are the proofs in Coq of 1 is not equal to 0, and the proof of 2 + 2 = 4. Well, I just want to revisit this proof for a second. Because it's a little bit of a cop-out to just say inversion in H. I think we can say apply Equian Raffle in H. Oh no, we can't. We can't, never mind. Because obviously we can't because they're not actually equal. Whatever. I mean, the tactic's just so powerful that it's unfair. So for reference, these are the proofs of 2 + 2 = 4 and 1 not equal to 0 in Coq. You can prove the axiom of choice from nothing. Well, yeah, it's just that the system is so powerful. I just want to understand MetaMath and how can you embed. We'll get to that in a minute. back to MetaMath. We didn't learn anything from writing that in Coq. And I mean, it's similar to the proof in 12th, not 0. Oh, yeah. Oh, you proved not 0. Oh, wait, what? I don't know what that stuff means. You can do this in Coq too, I think. Prove things about the proof. Now, what I eventually want to do is use machine learning to rediscover all of math and prove Fermat's theorem, but... Wow, Nano Danger 7, 18, congratulations. You end up in prop. Oh, yeah. Props and sets and types. Don't get me started about fucking prop. That was why we went to MetaMath in the first place, because we got angry about prop. Yeah, but you can, because I think it just builds constructs on top of constructs. This was mentioned in the Coq guide. How about MetaMath? Does MetaMath have any of these problems, or is MetaMath just perfect? And we just need to figure out how to use it. Like, I want MetaMath because its kernel is so simple. Idris has the best solution for it. You do a topological sort, sure, and then you can build. Yeah, well, no, I mean, look, so okay, like the type is lower in the hierarchy than prop, and then you can build types on top of types. I don't really know. I don't really understand what any of that means. Like, it has something to do with Russell's paradox. Here, we finally got a Russell's paradox, unlike the Russell's paradox troll from before. How you could use Russell's paradox to prove everything. No, that's why you have this. Isn't Russell's paradox the reason you have a hierarchy of types? It's a different paradox. Omega paradox, we're gonna learn on stream. Pokemon Omega paradox. Math. This is hard to understand. Look at these, man. Just one of these, all right. It's some of these. Once we understand what all these are, we'll understand what we're doing. Sold the razor. It's gone. No more razor. All right. We're still trying to prove that 1's not equal to 0. We were making some progress on this. Maybe. I'm not sure. My proof does not verify. Just getting back to my REPL. Okay, we're trying to prove 1's not equal to 0. I know a way to prove it. Now it's an axiom. There we go. Now it's an axiom. Girard's paradox for type theory. I've heard about this one before. Yeah. No, this is the one that the Coq documentation talks about. Yeah, but it's just, yeah, it's Russell's paradox, just formalized. But we can't get distracted. We have to prove that 1 is not equal to 0 in metamath. We have an axiom that says anything with a successor is not equal to 0. And we have a definition of 1, which says that 1 has a successor. But we just need to figure out how to plug them in. This is where I think I actually talked about Girard's paradox. Oh, and then there's S props, and S props are new, and they upset me because they just showed up. Wow, maybe after we're done with metamath, we actually will be able to write a verifier for Coq. Did they talk about? No, it wasn't Girard's they talked about here. I must have read that somewhere else. Okay, what are the unbound variables in all a lim? Only, well, so x, t, and phi. So I suspect we know what x is, and I suspect we know what t is, and I feel like I've done this already before. And now phi just has to be any well-formed formula, which I think we'll write this one. Now, binding t. Oh, we bind t first. So it was t0 var x. Yeah. Okay. Implies this equals this. So let's see if we can break it up. Implies for all x x 0 not equal to successor x implies for all x x equals 0, x is not equal to successor x. If for all x 0 is not equal to successor x, then for all x where x equals 0, 0 is not equal to successor x. That was still... But at least now we have... Let's just search more for equals xt. Let's equal xt. For all x and then maybe we use this one. I don't know why there's an if and only if. Prove 1 equals 1 from x equal x. Well, I'm not even sure what x equals x means as part of the problem. They don't prove anything here. They just define the system. We have an axiom of reflection. Yeah, we have that. But that only says things about terms. Here's the axiom of... No. This is propositional logic. Here. Axiom of reflection right here. Yeah, and then equality bin op is like factorization. phi be a well-formed formula? Schoenflieg's treatment, we use the term designator for a sequence of symbols as either term or well-formed formula. Basic result says that each is a bound variable. Maybe I don't want for all a limb. Maybe I need ones that have two hypotheses. And one of the hypotheses says 0. X can't be in chi. Alright, so maybe it is this. Let's try phi equals not 0, not equal. What about this? And chi is this. And x is x and t is 0. And actually, this is phi and this is chi. And then I run all limb 3 on them. So I get all limb 3 will tell me for all x equals t implies not equal to successor of x is not equal to I don't even know why they're 2. I got them backwards. Is that right? Yeah, they like... This is weird. They shouldn't have written it like this. I don't know. Should we try to look up an answer? Or should we try to get it? You know what? Let's try to do search. Let's do search. That's what we're trying to prove. Let's write a searcher. Because is this a programming channel or what? Let's introduce a new magical let's introduce new magical syntax to proofs. Where you can just write the word auto, and it's going to try its best to run an automatic proof. Let's write that. You're supposed to be able to put question marks in proofs, actually. So what if I run the real MetaMath on this? Not proved. Search. Oh, this is a stupid kind of search. This isn't the kind of search I want. Okay. I'm going to try to write a search. You know what? Let's just do search in a REPL for now. So you see what you guys see what I mean by search? May not be easy at all. You basically can't narrow down the search at all intelligently by type since the types are so simple. Yeah, that's kind of true, but there's just so few choices. Yeah, it's such a weak system. Yeah, all right, I agree. All right, let's try to prove this. Can we prove this? Right, because it should be just as true for y as it is for x. So, to be clear, this works, right? If I just type in the axiom here. No. Oh, I gotta do var x. Oh, because I can do binding there. Okay, so I can also prove it for y if I put y there. So that's actually an unbound variable. Oh, that's cool. I understand something. Okay, that's exciting. That is exciting. But if only it was an unbound term. All right. We can read the 2 plus 2 equals 4 trivia. I didn't read it yet. See, but we don't have AX gen. Because this is in set.mm, not in piano.mm. It's a different basic system. I don't really see something equivalent to it either. All right, let's work back from modus ponens, right? So we want to show we want to say psi equals this, phi equals this. Actually, no, even better. No, this isn't exactly right. We want to show this. So, yeah. There isn't a language yet that's put together. The issue with more intelligent languages with more text types is typically searches among them are intelligently designed by the programmer. There isn't a language yet that puts together some way of learning tactics for complex types. Yeah, I mean, that's what I really want to build. All right, and then this is the definition of if and only if. I mean, this is clearly true, right? If this is true, that implies this. T0, T successor, no. So it'd be really cool if that worked. You wouldn't even need the successor. The problem is that T0 has type term, and this thing is expecting a type variable. So I think one of the things that I'm going to do soon is I'm going to write some decent syntax around this, because MetaMath syntax is unbelievably bad. But first I want to understand like how these things work so I can get to what appropriate syntax will be. Oh my god, for dinner tonight, oh, we're gonna solve this and we're gonna get dinner. That's gonna be a good day. And get out of here with that keyboard shit. I know you're trolling. Oh man, we're gonna write some sick syntax for this that's gonna allow like variable assignment. You're gonna write it in like SSA form. Caledon. You've told me about Caledon before. Is this your thing? Probing style inference on top. Like, I want to keep pro-blog or pro-log. Problog. Oh. Oh, no. Probabilistic programming is a scam. Probabilistic programming... I met this really smart guy from Uber who was working on the language there, and like, he's really smart, and everything he said was correct. But at the same time, I have no idea what the actual uses of probabilistic programming are outside of like the contrived examples. I feel like you like probabilistic programming is another one of these things that deep learning is just better than. Yeah, and you can say the languages are shit, but I think it's more than that. Yeah, Pyro. Yeah. There are uses though, but like, what are they really? Yeah, the idea hasn't been developed enough, maybe. Well, this is almost what I want. Yeah, I don't know, man. These things don't seem useful. I want search that will fix bugs in programs for me. Is my end goal. Backspace.ai. Alright, let's see. That's the internet. Wait, which team? Which programming language? Poblog? Psi. We'll get back to that in a minute. Let's go back to this for now. No, not proof search. No, I wanted a. I don't even know if this stuff is right, because there's no proofs here. It's just all definitions. I would assume they tested it. Are there any definitions anywhere? NF? What is NF? Classical first order logic with equality. Let's see if anything else mentions this. Nope. Yeah. Be the right type. How do I turn variables into terms? I know how to turn terms into variables, and that's with tvar. But how do I turn variables into terms? Viter. Yeah, well, that's not a real thing. Like, maybe I'm not even allowed to phrase it like this. Maybe this is actually impossible. Because I don't see how the variable's ever going to get replaced by the term. Like, I could even... This is right. This all a limb thing. I wrote it out. And then... All right. This is right. Now I want to use modus ponens on this. And we're going to write something that's kind of what I want to say. Okay. We're going to write modus ponens on this, and we're going to figure out how to generate this for all x statement from the axiom. We can turn that into for all x. And then we'll do modus ponens. Yeah, because that expression is phi. Okay. This expression's phi, so we just need to figure out how to add it for all. Yeah, oh, this might be it. I don't even understand why. What is phi here? I don't understand why I need a phi here. Can I just say, oh, well, that's with an implies. I don't even need an implies. I just want to say, like, if thing chi, then for all. I mean, I guess I could just throw true in there. Like, phi can literally be anything that's true. I'm not sure why they had to write it like that. But yeah, if we go to alpha 2, let's try alpha 2 with phi equals true, chi equals this, and x equals var x. So, what is true? How do I actually get true? I mean, alpha 2, I just basically want to specialize alpha 2 to say phi is just true. And then I'll be left with this statement. And then I could modus ponens and just be left with that. And that can be a temporary proof. We could prove that. We'll get rid of the implies. Okay. What's just true? For some reason, I'm hoping one of you guys is going to solve it. What if I just put in phi? It doesn't even matter. Okay. So we want to do phi is just with phi. Oh, no. We actually have to show... Maybe it's okay. That's just... No. That's just the formula type phi. Why doesn't phi have type of turnstile? Okay, so that's what that is. alpha 2, we have to put in chi. I have a thing to build chi. This is chi. And then x is just var x, and then alpha 2. Binding, what? Where do I only bind? What? Why is psi even in here? Oh, in order for alpha 2 to be true, I have to already have alpha hypothesis 2. Ah! Well, okay, we first have to show implies phi chi, which we're going to have to get using the axiom PAX1. Oh, sorry. Var x PAX1. There should be something that just basically lets me say it doesn't matter. Yeah, it's this. Or not. It's like modus ponens, but different. Like, are you kind of modus ponens but backwards? Implies phi. Implies psi phi. That might be what I need. If phi, then psi implies phi. And it's a little confusing because okay, phi equals, we keep psi unbound. Does that work? Psi AX1. No. Oh no, so we don't actually want it to be PAX1, we have to spell out PAX1. Which we've done 7 times now as this. Which, you know what? I can just specify. All right, let's just do that. PAX1 with. And that proof of this WFF, that equals this. So we don't have to keep typing it. Restart my MetaMath. What? that has an unbound x, we do var x that. Okay, good. Okay, so that's that as a well-formed formula. Actually, in order to be consistent, what if I do that? Polish notation. Now we say this, x1. Okay, okay, look at that. Oh yeah, yeah, we're getting somewhere now. We're getting somewhere now. Okay. So now we have that. Now we can specialize alpha hypothesis 2 by saying wait, no, are we back to that yet? No, no, we still have to use modus ponens. We have to use modus ponens to just get this, which we should be able to do by saying this is actually just PAX1, which is entered in as true. So that's the min. That's the Maj. But if that's the Maj, let's just say psi. So PAX1 it doesn't show you how to construct the hypothesis, but maybe that doesn't matter. No, 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 no. PAX1 is the min, but then to actually construct the other one, we need that, which is that statement. First bind the variables. So we bind the variable phi as this. We bind the variable psi as that. We use that for the min and that for the Maj, and then we use modus ponens. Put the WFF over there. Pop from an empty list, okay. Phi, psi. Yeah, no, we got a var x before that. Wrong type. Did I get my binding order wrong? Oh, no, we have to bind var x to the actual axiom itself. There, too. Compare implies not. What? And Maj compares that to that. Okay, that's not right. Oh, no, sorry. Psi is not well-formed formula psi. Psi is that. Which we have to construct. Implies. psi is not psi in that case. That's wrong. We have to use... How do I get implies? I can just say implies, but we're left with this psi. Oh, it's just a bin up. So I can just use the same thing I used for the other bin up. T bin up. T bin up, but psi implies var x WFF PA X1. Let's try this. Okay, issue. Make sure that parses first. That does not parse. What's a log bin up anyway? Oh, with log bin up. Log bin up implies this. But no, that's backwards. Log bin up implies this with psi that. Is that what we wanted to show? So we replace this with that. This is becoming unwieldy. No. Okay. We're trying to do modus ponens. No, so we want to know what psi equals. This is a good construction. We just want to show that in order to prove that. And then we're left with that, and then we can put that in alpha 2. So it's a little annoying because that's actually psi. So why don't I call it something else? Chi. It's a dash chi. I don't know why it's a dash chi. Maybe that's a typo. If I get to actual neural proof search, I will let you know. Someday. This is a slow dream. It's the slow dream. All right. So this expression here is psi. So we want to say psi equals imply chi naught. Phi equals equals this. Oh no. There's no implies there. Phi just equals this. Which is just this. And then this, we're left with log bin of implies Is this going to get us what psi is? Move it over a little bit. Implies chi not 0x. Okay, so that's psi. Now we have to show min e, which is var x pax1. And now we have to show the other thing, which is this almost. We have to show match. This is match. Now that we've assigned phi, psi, min, and match, we should be able to just run modus ponens, and that should work. There we go. Sweet. Temp proof. No. Call it one intermediate. Yeah, okay, cool. Okay. So now we have implies chi, not that. Now we should be able to go to alpha 2. Implies phi chi. Yeah. So in one, so phi is chi. Wow, that gets annoying. This language is god awful. And chi is just, I believe, well-formed formula, opinion, or arithmetic 1. And then alpha hype 2 is int 1. And then alpha 2. No, so chi, but we have to specialize this for var x. And now we can't just use int 1, we have to specialize int 1, which I did up here. Phi is chi. This is the, not the axiom, but the formula specifying the axiom. This is the specified in 1 and then alpha 2. Px, Pa. Pop from empty list. Binding x, phi. Oh, we have to bind x. Yeah, because for all x. Okay, cool. All right. I'll verify chi and x are disjoint. Wait, what? No, they shouldn't have to be. Only phi and x have to be disjoint. And I know that phi is chi and it's all, oh, I can't actually do that. And what if I just call this chi? Psi, I mean. Does this fix it? Var y. I don't know. This might have all been a waste of time, but we're making some statements. Yeah, like this stupid language reuses the same variables over and over again. Okay. Let's go back to see if anything makes more sense now. All a limb. For all x, for all x phi implies, yeah, so I'm trying to generate for all x phi. Like for all x, the well-formed axiom. I mean, ideally what I want to prove right now is just this. This, for all x, not 0 sx, right? So we have this, and we want to prove this. Because that's just the axiom, so we want to put the for all there. And then once you have the for all there, we can run all a limb on it. And then we can figure out how to deal with other stuff. We gotta figure out how to get that first. So I was hoping that alpha 2 would get me this, but now it's just complaining because phi and x are not disjoint. Okay. So let's go through what each of these things is. I don't even care what phi is. Phi can be well-formed formula psi. I think this is just a bug. This should actually work. This is just a bug in how I typed it. Binding x, phi, and chi. Bind chi to the formula. Verify psi and x. Disjoint. Oh, I might just need to promise that. I don't really get this. I guess this is only true. D psi x int 1 int 2 prove this using this. No. Produced implies oh, it worked, but it didn't make what I wanted. Oh, no, because we're left with still and implies psi. not sure how I expected that to go away. But yeah. Again, okay, now let's try for the thing that we want, all a limb. We still have a psi implies there, but like, what's frustrating is psi can be anything. Like, I should be able to just get rid of that. Can I do this with modus ponens? Because I don't start out with bot. Chi. Sorry, moved on. This phi is set. No, it's not set. Phi is defined up here. Phi is any well-formed formula. Right, like here, I'm in the REPL. These are my equations, these are my constants, these are my variables. Let's just cheat for now. Let's even say I could get the thing that I wanted. This. What? Why is that wrong? Oh. Yeah, so if I could get that, then we can work on all a limb. Okay, implies for x phi, so we're going to bind x to x, we're going to bind phi to var x this, and we're going to bind t to t0, all a limb. Well, obviously, okay, that just works. But now we have to use modus ponens with cheat to get rid of this. Fundamentally, we still can't do the term substitution. Oh. How do we actually do the term substitution? Nootropics aren't going to make you smarter. Years of practice might make you smarter. And the only way to get years of practice is to start by practicing today. We can make a term out of a variable, but we can't make a variable out of a term. It's so frustrating. Like these things that I'm trying to prove may actually not be provable. And I may just have to phrase the whole thing in a different way. Right? Like you just say out of band, like obviously if for all x you can just put x in. Our next step shows that it suffices to prove the following special case of this axiom. The variable x does not appear in the term t. The variable x does not appear bound in phi. You see this as follows, which is alpha equivalent. The variable y does not appear in the term t. No bound variable of psi appears in the, okay. Here MetaMath can prove the equivalence of that and that. But in a view of 1 prime, the instance of all elimination see, basically the thing that I'm missing is the thing that's going to look like this, right? X equal, the formula for all x, for all, no, that's not right. X equals t implies, that's not right. For all x phi implies, yeah, okay, so all elim is saying something that makes a lot of sense. If for all x phi, then for all x, x equals t implies phi? What? For all x phi implies, I know I did this before. for all x equals t implies phi. I mean, yeah. That won't actually allow the substitution. This completes our discussion of for all elimination. Yeah, what do you mean write it in English text? Like, I'm not sure exactly what to write. There has to be a way to prove this. For all x equals 0 implies... This doesn't even make sense. Like what does that mean? For all x equals 0 implies the axiom. This is a stupid statement. Meaning that phi implies itself? Not really. So, yeah, is there a programming language that consists of a few simple rules? I mean, this is the closest you're going to get. This is basically what it is. This is why this is so attractive. But this is just bullshit. x equals t implies phi chi. From the definition of exists. Yeah, the syntax is terrible. Well, we've given up on 2 + 2 = 4. That one, I don't even know how to start to get to, because we're going to have to plug in lots of, well, variables for that. Oh no, well, so we can just like apply this axiom a bunch of times. But eventually we're going to have to substitute in terms. Maybe I'm overthinking this. Well, yeah, and then eventually I show that like x is just x plus 0. Then I'm left with the successor of successor of successor of successor of 2, and that shows that it's the same. No, but I wouldn't actually be left with that because I wrote out what I want to find for 2 + 2 = 4, right? Well, that's been a while ago, but I want to get to this. Fundamentally, 0 is a term and not a variable. I can't say that like let x = 0. Or can I? Like eventually we do. All right, let's just go for it. Let's try to prove 2 + 2 = 4. So we have like, we can say like var x, var y, PAX4. Okay. We're left with that. Successor to plus xy equals that successor y. Let me see if I can do that like twice. Can I say like var, if I just say var x, I'm left with variable x, and then how do I make the expression the successor to x? Like I can do like t0. And then I can apply the successor to that. But what if I want the expression the successor to 0? Oh, I have to turn it into a term first. So I say like var x t var t successor. Okay. And now it becomes a term. Huh. Oh. This is a term. Okay, so if I'm trying to prove 2 plus 2 equals 4, we have PAX4, and we can put in var x and var y. Putting in var x and var y is not all that interesting. Because it just gives us the same expression, but bound. So what if instead of var y, I nest it and I put in this. No, well, of course not how the syntax works. No, but PAX4, that won't be a variable term. In fact, the only variable terms I can put in are var x and var y, because there's no other way to get variable terms. Man! Because once I've turned it into a term, I can't put it into the shit anymore. These axioms are useless. Ah! I'm trying to cheat now, guys. And we still haven't made progress. Looks like we can turn variables into terms, but we can't turn terms into variables, no matter how we do it. Even if it's for all. What are all the terms? Key 0. 0 is a term, and there's no way around this whole 0 is a term thing. I hate when I don't solve things. Those are all the rules for if and only if. Equality, transitivity. Equality of successors. terms are well-formed formulas. They're very similar. I can turn terms into well-formed formulas, can I not? Well, a log bin op operates on two well-formed formulas. So can anyone find any piano arithmetic proofs online in MetaMath? Let's write MetaMath. No. Has anyone actually used this? For alpha equivalent, if n equals m, okay, if we had something that said, if for all x, they don't share a type though. And that's the problem. We can't even show that they're the same. Basically, for all x, f of x, and x equals t, then f of t. But t and x don't share a type. Unless I can turn them both into well-formed formulas. Wait, t and x do share a type, just not in the way I want. I can make them share a type, and their type is term, if I do t-var, var x t-var. Then it's a term, x. So that's the same type as like t0. But the problem is the axioms only say things about variables. You found something? Yeah, so the problem with this one is they're doing it in set theory. We can look. Let's see if we can, maybe the set theory one helps us. It looks really complicated. Like, I don't have AXGen. No, this is very different stuff. They're not using, they don't have terms and variables. Oh, okay, let's see what these things are. Well, yeah, but these aren't, unless they're about MetaMath. It's not that I don't know how to do the proof in piano arithmetic. There's a chance this is broken. Like, I'm Oh, this is new foundations. Yeah, like, okay, so in the MetaMath folder, there's multiple, like, systems. Okay, let's go on GitHub. And let's look at the history of the file. Yeah, let's contact the author. Yeah, that sounds reasonable. Let's get him in here. Wait. It's not here. Oh, Robert Solovay. But like there's too much stuff here for this to be wrong, I feel. It has to just be something I still don't understand. Yo. Who wants to get Robert Solovay in here right now? We will slightly deviate from the treatment in Appendix C of the MetaMath book. Does he have stuff on his webpage? I feel too bad to call the guy. But I would send him an email. But no. That's really cheating, guys. Even the internet's not cheating. Once you bring other people into it, you're just a cheater. Okay. Aha! No, guys, I think I have something figured out. The whole thing is I shouldn't be looking at variables because we can turn terms into variables. But we can turn variables into terms, and then we can use the equivalent stuff to replace the term and not the variable. I think this might work. Are you sure? I mean, because, like, fundamentally, I was thinking that we have to turn this stuff into zeros, but I could do it the other way around. Like, I could turn the 0 into an x. I gotta eat some food, guys. I'm hungry. No food. Oh, this is terrible. Oh, this terrible lack of food. All there is bananas. All we have is more bananas. And rice. Oh, alright. Got a good clump of rice here. I'm not ordering a pizza. It's nasty, man. You gotta eat well. Tell you what, I gotta work out. Okay. How does this even work? How can equality compare x and t? Don't go to. Don't tell me what to do. You get a timeout, and next time think about telling me what to do again. Alright, so you get this, but yeah, that's right. You'll never get to read the brilliant shit that he wrote. Because it's gone! Alright. quant. Like, I don't understand how to use any of these. No, it's not a step towards a goal. It's just to do it, okay? Each one in the role of... Here was a quantifier. Phi implies then we just need to invoke the axiom alpha 2. Okay, so I did invoke the axiom alpha 2. We did that. We now turn to the axiom of for all elimination. To state it, we introduce the familiar notion of substituting a term for the free occurrence of a variable. So let phi be a formula, x a variable, and t a term. By phi t replaces x, we mean the formula obtains simultaneously replacing each free occurrence of x and phi by a copy of the term t. A more rigorous definition would proceed by induction on the structure of phi. We said that t is substitutable for x at the free occurrence or x at phi. So we could just figure out how to put the term 0 in terms of x. If no variable occurring in t, which 0 doesn't have any variables in it, falls under the scope of any quantifier of phi. The final group of axioms of predicate calculus that we need to derive have the following form. For all x phi implies you can replace t with x in phi. Okay, that's all sensible. Our next step is to show that it suffices to prove the following special case of this axiom. Phi x and t satisfying the following. Whew. Some people actually know what's going on, okay? And those are the people we look for. And the people who aren't there, well, this is why we put, thank you, this is why we put subscriber only chat on. The variable x does not appear in the term t. No bound variable of phi appears in t. The variable x does not appear in phi. So this is fine. Clearly find a formula. Under the hypotheses 1 through 3 just given is equivalent to okay. So basically cheat 2. It says cheat 2 is equivalent. Now I'm not sure that actually means I can turn cheat 2 into. Let's replace cheat 2 with an actual proof. Just to make sure that I'm understanding what's going on here. Okay. Implies for all x, not that. So we just need to use modus ponens again. Phi is, this implies so var x phi is this. So it's going to be this with some for alls. Yeah, I got to put for all x on there. Quant all welcome formula quant, is that right? Quant for all. Binding phi to that. Oh, I need a var x here too. Or maybe the other way around. That's right. Okay. So that for all x not is the this is the phi in modus ponens. This is the maj in modus ponens. The proof of that is cheat. Okay, so this is just, it's variable substitution. So phi is this, psi is this, min is this, maj is this. We just need to fill in what psi is. And this is really all because the syntax is so atrocious. So we're left with var x, t var, t0, bin pred equals well-formed formula atom. We have var x, the axiom, and then we want to put an implies around that. Log bin op implies well-formed formula bin op. Yeah, so that is this psi. Is that right? Here. Implies not, no. No, this isn't right. Well, it seems like first off I got the implies backwards. Looks like the only thing I have to do is put a for all x around it. Okay. And then ax and p. Prove this, and the proof goes like this. This, well, this is the proof. Who thinks it verifies? Does not verify. Great. That's phi. That's psi. Oh. Var X cheat. Yeah. Notice how this and this are equivalent. And then this is this. So did we just forget a var x before that cheat? Let's put a var x there and see if that fixes it. Oh yeah! Alright, we just proved cheat 2. Okay. So now they claim that these things are equivalent. I don't know yet if we can prove cheat. If we can prove cheat, we're not even cheating anymore. So the reason we're cheating is because this is an A and not a P. So like you can just put an A there and then you don't actually have to write the code for it. But we proved cheat 2, so that's good. I mean, it seems like we're on the right track. But this is very concerning for like proof search. Because like I got a neural network with a lot of weights and I'm putting a lot of effort into this and like it's really hard, which makes me think computers aren't just going to be good at it. So we've proved cheat 2. Now, if we can get from into to cheat, that'd be progress 2. But I'm not exactly sure how to do that. So we can say like woof of psi var x, and I think I did that backward, into, I did it backwards, var x with psi into, well, because of the stupid disjoint crap. You have to show that psi and x are disjoint. I can put any well-formed formula in there. We don't talk about that here. Let's see. It's okay to replace fee. It has a free variable there. Can I use modus ponens again? Is it possible in here to just... Because I don't have anything that... I don't have the min. I don't have anything that says, like, this is true. Which is why, like, maybe this was the wrong direction to go. But I can substitute anything I want in for psi, can't I? Right? So I can just take anything that I have an axiom for. Why is this not right? I just, in order to get cheat, I just need to take anything that I have an axiom for and call it psi. Call it phi in modus ponens. So phi is any well-formed formula that I have an axiom for. And it just can't have any x's in it. But, like, I don't really understand this because it seems like I can just use any axiom. But let's just try it. Phi is... I mean, let's just use the same one. It doesn't hurt. Var x that. Min is var x cheat. Psi match. Okay. We know that match is int 2, and now we just need to write out psi, which is just this. So we can copy that, and we need to put an imply psi around it. Imply, we don't know what it implies, so how do I get implies? It's absurd that I have to construct these. Log bin up implies log bin up. Not cheat. No, that's not right. No, this is the axiom. PA ax 1, because that's a true statement, and then that's int 2. And then AX NP. Int 2, so I need the expression this var x, is that right? Or it's probably double var x. Yeah. Var x, this int 2. What? I don't get it. Binding x. Oh, verify x and x disjoint. So I can't actually use x here, I have to use something else. I think for all of these I don't actually need x. This is var y. It's going to be a little more annoying to develop, but formula not those can all still be var x's, and then we're going to change this to no cheat proof. It's the same as cheat because we're proving it and it's not an axiom anymore. And let's try this stuff. Odds that this verifies, low. Does not verify. Wrong type. Not sure exactly how deep in there's no wrong type, but is that right? Okay, that's that. Implies for all x. No, so that's backwards. With psi. That's not psi. That's just a restating of match. So I actually just want, I don't need the implies psi stuff. It's just this. So that's psi. Implies that it's a proof of psi, and that's the proof of phi AXMP. Wrong type. Let's add it. Okay, let's add some debugs. Log.warning. Expected type got type this. So it expected VT and no. It expected this and it got this. Expected type well-formed formula got type var. While binding psi to x. Why did it try to bind psi to x? This needs better. everything. It's a well-formed formula, as it should be. That's a well-formed formula, as it should be. The only thing I could think that's wrong is how I'm calling Madge. Maybe I should call it in the other order. Actually, that's probably right. Ooh! All right. Okay, that worked. Now, we can get rid of cheat, and we can replace my usage of it with no cheat. And now we're not cheating anymore. Yeah. So what have we proved? We've proved for all x implies... Basically, okay, we've proven for all x equals 0 implies, oh, I don't think that's quite what we wanted to prove. It's close. I think we wanted to prove or no, maybe that is what we wanted to prove. Well, it's certainly true, and we proved it. Oh man, it takes forever to prove anything. How does anyone do math? Yeah, good point, I should commit that. Much proven. Yeah, this is proof verification. It passes the verifier now, somehow. No cheat is an interesting thing in and of itself that we proved. We proved that the axiom was true for all x, not just like itself, right? Like we took the axiom and we proved that it was true for all x. So yeah, no cheat is interesting. Cheat 2, this is what it was saying though, if I could prove that. Use axiom 2. See, T is substitutable for X in phi. For all x implies for all x phi implies x for all x if x equals 0 then that. Well, it's definitely, I mean, you ever heard of the Curry-Howard correspondence? Math and proof with maths and Curry-Howard. It basically says that proofs and programs are the same thing. Okay. Okay. Can we prove that? Can we prove if x equals 0, then implies that? Right? So can we prove that? Like that almost seems like it should be some it's probably not part of propositional logic, but they're both terms. See, that's what's interesting about that. They're both terms. Can we prove this anywhere? For all x, for all y. No. So this is alpha substitution, definitely. This is actually if and only if. Like that's the template for like an alpha substitution, right? It's not alpha 1. It's not alpha 2. These all involve for alls. Here's like the definition of if and only if. And the definition of and the definition of or. That's not what I care about. These are the ones with two terms. So we could show that if x equals 0, then 0 equals x. And we can show that x equals x. Who thought this would be so hard? The timeout from George. What do you mean the timeout? You think I'm going to give up soon? This is what I'm doing tonight. I am hungry though. We might have to go eat. Dude, hacking is super important. We're trying to prove that 0 is not equal to 1. Chick-fil-A's closed. Do this Sunday. Free in fee 1. See, these people they have a different way of thinking. Oh, the font config. Font config stream sucked. Okay, let's think about all the lim 3. Let's think about how we'd specialize all the lim 3. So we'd want to say chai and this is why I just wrote this out with the term. I want to say chai is T0. We'd want to say phi is var x t var. We want to say x is var x, and we want to say t is t0. That's not what we want. We want something that's going to really prove just chi. Or we might have used modus ponens on it. We need an implies chi. Now, there is a built-in implies chi there to the hypothesis. Huh. Can I prove that? Through like term substitution or something? You can do equality of this. What's a bin up? Only plus and times, that's useless. Nah. It's a bin pred. Equality. Not transitivity. It's his alpha substitution. Kind of useless. It's indeed true that alpha equivalence. The following concept is non-standard. The following is trim. I read chat. How do you end up with satisfying any of these hypotheses? All limb hype. case. Implies for all x x equals t implies phi. Oh, okay, wait. So, apparently, we want to say for all x equals t implies phi. X equals t implies phi implies phi tx. This will follow from the next axiom, which is inelegant but correct. Oh, that's why the chi's over here. Ah, because that doesn't bind there. xt phi. You see? Okay, look at this about how it implies. So we do have to use all of lim 3. Ah, okay. Yeah. So let's call this one no cheat 2 since we don't have to cheat for it anymore. Let's put in cheat 3. And cheat 3 is an axiom that says implies xt equals xt if the chi. But we'll do this in a scope where we promise that these things are disjoint. Actually, I guess we don't have to because I'm cheating, but we'll have to do it when we don't cheat. Now, when we want to apply all of lim 3, we just say x equals x, t equals 0, x equals var x, t equals t0. We actually want to say probably, no, that's not right. Phi equals, oh, well, so that's not actually. Whatever, we'll get back to cheat 3 later. But phi is this, well, or is just term, but with var x t var, and chi is with t0. We can test those. All right, we're getting close now. We can just give it the real name. 1 is not equal to 0. And 1 not equal to 0, all it says is the thing we've tried to improve from the beginning, which is that bottom, that, I'm gonna prove this with a proof. Yeah, so not 1 equal to 0. So the whole thing we've been trying to prove, we're getting close. Or another way to say that is just chi, right? Chi doesn't, well, chi's just the expression for that. Yeah. It's the well-formed formula, but it doesn't actually have the bottom. And then once you've proven all of lim 3, you just have to use modus ponens with no cheat 2. So let's just do this for a second. Cheat 4 axiom equals well, might even be just yo, this is a long stream. It's getting hard. This is a long proof. That's what I meant to say. Even if we've shown this. Ugh. Guess they couldn't find me. You see how to get there now. So we have cheat 3 now. Let's use term 3. Okay, let's use a lim 3. Let's use a lim 3 with the hypothesis. Well, first implies implies for all x to prove it, it's just going to end with modus ponens. So if Madge is going to be cheat 4, notice how this is this. So min is going to be no cheat 2. And then we have to build those stupid terms. So we can build no, wait, why is there an if and only if here? It's not right. For all x implies equals xt phi chi. What? Oh, getting stuck here. Okay. So that's cheat 4. No cheat 2 is min. For all x implies that. Okay. So we have to build min. To build Madge, it's just the one with term. T0 with term. And to build min, it's var x quant all. So that's for all x. Log bin up implies. We get to invert the implies, I believe. So this is actually just var x tvar. This which is that expression there, and then we want to talk about the equality. This log bin up quant. No cheat to WFF. We can just call this up. I hate that I have to build these formulas. This is just stupid. I'm just building the same thing that it already knows. It just doesn't know how to produce it. Yeah, so it's just no cheat 2 WFF. No, I put var x before it, but yeah. So for all x implies this is just this, but a different type. See, it's identical to this. It's just not the same type. But now I can use that as the predicate to my modus ponens. Not right. Expect type bar while binding x to. Okay. We have modus. Phi is this. Psi is this. Min is this. Oh. Var x that. So is this a proper min? Same as that. And then mad is this. Okay. We just have to turn cheat 4. Have you guys all been causing trouble? Damn, a lot of people timed out right now. What the hell is devirtualization? But I'm stuck on devirtualization. A lot of people causing trouble right now. You know, come on. Oh. Themida? Like the Packer? Devirtualization. Oh, that's funny. I don't know. Devirtualization. I think it's actually theoretically impossible with like homomorphic encryption and stuff. Okay. Focus. We just need to prove cheat 4. Now we can prove cheat 4 from cheat 2, but from cheat 3 by using the reduce rule 3. Lim 3. So this actually shouldn't be too hard. No cheat 4. Oh. Change it to no cheat 4. Proof of this. So we're going to run all lim 3, and that's going to yield exactly what we want. But we just have to set up the hypothesis, which is just var x cheat 3 is the hypothesis. And then x is var x, the term is t0. Phi is this, and chi is this. This is exactly what I wrote for this. Types are wrong. Oh, we probably bind the term before the, is that all it is? Yeah, cool. So no cheat 4 works. Now, if only we could prove cheat 3. We've officially proved that 1 is not equal to 0. And we're not even going to try to prove 2 plus 2 equals 4, because that was way too hard. We're changing the name to JK. 1, 0 is not equal to 1. Because 2 plus 2 equals 4 is way too hard. And we're just going to try to prove 0 equals 1. And if we do that, I'm very happy. And this was way harder than I thought it was going to be. This language is totally unusable. Okay. So do you see, at least for you guys to understand like a bit of structure, basically, this statement here is what you're trying to prove. And then like this is the proof. If I use $A, I don't actually need to prove it. I just make it an axiom. If you use $P, you prove it. Now, the problem with just making it an axiom is you can make things that are totally not true axioms as well. But it can help you like flush through the structure of your proof. So if we can turn this A, see the problem is if I just turn it into a P, well, we get an error. And I can give it like a bogus proof, and then we get an error. Those are actually parsing errors. This is a valid proof now. Now we get assertion errors, right? So we're going to get errors until we put the right magic words there. And, you know, we added in the magic words for here. We added in the magic words for here. So now we just have to figure out how to get the magic words. And I don't really know. This one's going to be really hard. So what this says in normal people words is if x equals 0, then zero if x is not equal to 0, then 0 is not equal to successor of x if and only if 0 is not equal to the successor of 0. I'm looking at this equality congruence. Looks kind of right. I promise you it's live. Who said it was recorded? Quantum Computing MIT. If I pre-recorded this, how would I know that you were Quantum Computing MIT? Yeah, I always look. I'm like, man, one of these days my chat's gonna be smart. Sometimes my chat's smarter than me. Sometimes my chat gets things I don't, and that's when I love my chat. Okay. We're making good progress. Okay. We know at this point that MetaMath proves, so we're not going to need anything past that point. And I already used all a limb for no cheat too. This has the same predicate. Takes to go from MetaMath, Coq. Well, Coq is much more powerful than MetaMath. Why don't we first just try to go from Coq to MetaMath? X equals 0 implies you only used alpha 2. It's not that we have to use them all, but like maybe the other alphas are helpful. Implies phi. Phi implies no. All X. Oh. This one's interesting. Maybe. Let's write it out. Let's write it out in normal people words. For all X, for all Y, X equals Y implies phi psi implies for all X phi for all X psi. Do I think P equals NP? No. happens if I try to put this in real MetaMath? Nested comments are not allowed. Oh, they got me. Wait, who's nesting comments there? Oh. I think this stuff's all crap. Cheat 3 was not approved. Cheating cheat 3. What is this trash language? It's MetaMath. I know. You gotta watch the other stream where I scream about how much I hate MetaMath because the language is so trash. I gotta eat a little bit more rice. Oh, I was gonna go out for dinner. So much for that. We have rice and bananas, you know? Rice and bananas are what we got. How long did it take you to learn it? Today. So, no, it's a simple language. I wrote, so the compiler that I'm using for the language right now, I wrote. I need some water, that's what I need. Angle, we're gonna try to write search to do this next stream. And then we won't have to do this stuff by hand anymore. That's the dream. Ban your mod? Who's my mod? Why should I ban them? Because they've been banning other people? It's probably good. They were probably bad. Oh, ban my mod for saying that JavaScript is trash. Oh, JavaScript is such trash, man. You spend any time in that ecosystem, fuck that language. It's not even that the language is that bad. I don't know. We're not ranting about JavaScript, guys. We gotta stay focused. We gotta prove cheat 3. I mean, the JavaScript language is not bad. I don't mean to insult the JavaScript language. I mean to insult the JavaScript ecosystem. Oh, we gotta eat more rice, guys. We gotta eat more rice. Just a bit more rice, and then we're gonna prove it. We've making so much progress, I feel. But the thing about proofs is you think that you're making progress, but you have one tiny thing wrong, you're just all wrong. Might be an unfixable error. And guys, 0 might equal 1 after all. which the reader should verify is correct. Does for all have to apply to variables, or can it apply to terms? V and variables. For all x, the proof of proposition 3.1 is now complete. We apply it to phi and get that metamath proves. Construction of such proofs is by induction. Okay. The first case is when psi is atomic. This case is easily handled using the equality axiom. So you can use the equality axiom if the second case is when the principal connective of phi is a propositional connective. Okay. Let's say I just wanted to prove this. Like this. Right? See, I just wanted to prove that. Psi is atomic. Like quant Y. I'm putting a quant Y around that. Oh, no. Okay, wow. I'm writing this wrong. The second case has nothing to do with that stupid formula. The second case is when a principal connective of phi is a propositional connective. This case follows easily using propositional logic for our inductive hypothesis. Propositional logic. So we have a successor function. Like, let's say I wanted to prove temp 3. Just temp 3. So, like, that's obviously true. T suck. It's like these kind of things. If and that's just an expansion of if and only if. If x equals 0, and s equals s, is that a term? Let's just try specializing this one. I like this one. So var x t var t0. And then s that. S label not found. Let's try like TT. Oh, we have bin preds. Yeah. It's backwards though. X equals 0, t equals t implies that and that. Why can't I put the t's here? Oh. Yeah, here. Oh, yeah. Oh, yeah. Okay. I knew it was the EQ or con. I knew that one looked good. All right. So now, I don't actually want TT. I want the successor function. Oh, maybe I could just do T suck? No, but they need a term. T-suck is itself not a term. Almost that. It's not exactly what I wanted to prove. Clearly true. That's not what I want to say. That's not right. No, that's just, no. What am I doing? This isn't right at all. Ugh. I'm tired. I'm not trying to show that. I'm trying to show that. It's so easy to just get things slightly wrong. That other thing wasn't even a well-formed formula. Guy Ross, thanks for gifting somebody a sub. That other thing wasn't even well-formed. That's just... stupid oh! Well... it looks like this is an axiom. It looks like this axiom is just called equisuccessor. So if I say equisuccessor var x, that was right in front of my face. Term 0. Tvar equisuccessor. All right, there we go. So you want the proof for that? It's just that. I don't even know where this if and only if comes from. See, there's 2 equals there, and this isn't right either. That's not. If only this stuff was written out in a nicer language. Okay, that, if and only if that. Zero. So, I mean, 0 equals 0, and successor x equals successor 0. Yeah, it's like a combination of those 2 proofs. This actually might not be that hard. So we have, if x equals 0, then successor 0. And we have that. We just need to combine these 2, it looks like. What is the term in this case? No, we want to use all of equicongra here. So we want to say if Sx in equicongra, we want to say S0 equals, we got to deal with the not as well. Not equals. I think that's, can bin pred be not equals as well? We can work that out, but okay. S is that, T0 is 0, and T1 is 0. And then we just do equicongra. Oh, and then what's bin pred? So yeah, this is what we really want. Bin pred equals, what's not? No, it's just a well-formed formula. All right, we have, so this will yield if 0 equals 0, that's obviously an obvious thing. So that's going to yield that. How do I put the knots in there? Oh, axiom 3. Axiom 3 puts the knots in there. If you have not, phi implies not. Oh, this is just, no, now this is just annoying. Because we're going to have to break out both of the if and only ifs into that. an easier way. Axiom 3. It's called metamath. It's totally incomprehensible. We're trying to prove that 0 is not equal to 1. Maybe like the transitive property of implies. If X implies Y and Y implies Z, does X imply Z? Yeah, that sounds right. This one's equicongruent. Var X T suck T0 T suck oh. Bin pred equals equicongruent, is that right? I don't think that is. Produced that, expected that. Well, that looks more like an ordering thing. Produced that, expected that. Okay, so now all we have to do is get rid of the and the implies. Oh, we'll just add it for now. Okay, so we should be able to get rid of one of the ends because 0 equals 0 is obvious. So we can prove that and get rid of that. We need the definition of and. temp 3c, prove that this implies equals, well, no, we want to go the other way around. We want to prove that 0 eagle, thank you. Yo, MetaMath's incredible. We want to prove that Sx equals S0 implies that. Yeah. So in order to do that one, make that one an axiom for now. I'm sure we can do it. Remember the time I tried to prove that the square root of 2 is irrational in coq? And that took a stream. Well, here we're trying to prove that 0 is not equal to 1. We have all of MetaMath at our disposal, and this is taking a stream. More than a stream. This is taking way too long. Okay, so if I have that, and then I can make temp 3d, which is a proof that this implies that. Get rid of the end. And I do this by using, there has to be an axiom schema for this. Okay, we have temp 3c. And we have temp 3d. 3b. We have that implies, we have that implies. Now we need to just use that joint implies thing. There has to be something for it. Oh, it's not written in the other notation. It's written in... It is, it's axiom 2, isn't it? Phi equals this. Psi equals this. Chi equals this. Okay. And I have to build those. I have to build those well-formed forms. Constructive math is infuriating. I have to build those. I have to build each one of those equations. To build each one of those equations, and then what do we get to? Get to this. Just call an axiom for now. We can use the same trick again. To get to this. We're going to have to write some syntax around this language before this is doable. Now we can show definitely going to be possible to show if you have an if and only if around a not, implies using AX3 we get to there. No, we actually have to use AX3 for the opposite, but it doesn't matter. No, that's right. We can prove G3G now. Why doesn't that comment work? Ah. Then here we can say B equals that, and chi equals that. Psi implies chi equals temp 3f. Implies psi equals temp 3e. Temp 3d. I got the proof in theory. This is unwritable in this language. All right, next stream. Well, maybe I'll come back on. No, I'm tired. I gotta eat. This is exhausting. Next stream, we're going to write some syntactic sugar around this language so I can actually write proofs in a clear form. This is... I don't know. I don't know if I'm just tired and can't follow this, or this is actually just impossible. Like, are people just writing this out? This is an unreadable language. I mean, they must be using something else to develop it. There is this Java tool that I tried to run. But you see, these are their proofs. So they're compressed. They must be saved by something, or like, who knows? We'll look into MetaMath 0. MetaMath 0 might be a better option. No, I mean, look, why not go with something like Lean? Yeah, if I wanted to go with something like Lean, I already wrote exactly what I'm trying to prove in Coq, and I did it in 10 minutes. So, like, here's the proof in Coq. Right, the whole thing is 23 lines. MetaMath 0 maybe put the right... I'm gonna read the MetaMath 0 paper tonight. Yeah, take a look on Git to see. I did. I looked all over for stuff. It looks like nothing's ever actually been proven with these Peano arithmetic axioms. For example, the core axiom is PAX1. So do a search for PAX1. The only thing that, well, yeah, you see, it's just things that are designed to parse. It's not like proofs. What language is this in? It's closely related to MetaMath, but has a stronger definition mechanism. A modular structure for proofs. Oh, that's what I was screaming about. Wow, every time you just like learn about new stuff. I mean, I guess I'm not the first person who's had the idea of taking MetaMath, but Lean's pretty nice. No, MetaMath was written by hackers. Oh, academics did Gilbert? Yeah, maybe. I'm gonna try to read the MetaMath 0 paper. But I gotta eat. Thanks for sticking with the stream. Can't believe we didn't finish it. You know, it's one of those things that, wow, I estimated how long it was going to take so badly. Hate when I don't finish what I set out to do, and then I lower the goalposts and I still don't finish what I set out to do. Host someone. I don't really know how to use Twitch. Who's streaming? Thanks for joining, guys. There'll be a part 5. There'll be a part 5. This is what we do on this stream now. We do math. We struggle with math. It doesn't get as many views. Sad. But I guess maybe because we struggle. If I was good at this stuff, I could explain it better. Night, guys. Say today's stream is gonna be better than yesterday's stream. This time my coffee is hyped this morning. Good morning, everybody. Good morning, Low Gang. No! My vacuum cleaner is stuck. I just want to show you what happened. So every morning I go out and I tell my vacuum cleaner that they have to clean the cloud. But check it out, it got stuck. It got stuck on some boxers and that was the end of that. Yo, but today's gonna be a better stream. Because what we're doing is search. Good morning everybody. Good morning. All right. So, remember how hard it was yesterday to like produce this string? So what I wrote was a search. So like here, we can tell it to search for this string. This string is produced by this program. So this is a program. A program is a sequence of labels and it outputs a sequence of math symbols, right? But the beauty here is I just tell it the math symbols. So you notice how they're math symbols. And it produces a string of labels, which actually is the program. So that's what we did. We also implemented forward search. Yeah, search forward. So let's just break that out a little bit. Forward search never fails, I believe. Yeah. It has the same API. All right, so now let me just bring up my REPL here. And we can do things like, say we want to do a forward search for equals, let's say equals 0, 0. Should work. Oh, no, that's not going to work. I have to give it a type. So I'm going to give it a type. There we go. Okay. Hit equals 0. Is forward search not returning? Yeah, don't return. I want to return X here. Get rid of hit. It's a little stupid. So now if I do forward search for this equals 0, 0, there we go, right? So this is the output of the program. And this is the program that produces it. So now if I run this program, you'll see that this is produced. How cool, right? So we can also do backward search, but right now it's broken because it's producing some modus ponens shit, which I don't really understand. But backward search is working for some things like, let's see, is that one gonna work? Yeah, that should work. So if I want to do a well-formed formula, There you go, right? So I search for this program and I do this. Now this program is 4 instructions long. So this is backward search. Forward search is going to take a long time, I think, but it might work. Let me just gate this behind if args test. I added in argparse as well. Now I'm redeeming myself. Yesterday's stream was shitty and I did a bad job and I should feel bad, but today's stream is going to be much better. Right forward search. Yeah. Okay, so asking questions like, what can this program be used for? You're missing the point. This is not to be used for anything practical. And if you're using it for something practical, you're doing it wrong. And see, look, it gets the same thing. So what's the difference between forward and backward search? So what forward search effectively does is runs all the programs. Forward search runs all the programs. I don't even think I gate it based on type at all because I can't know the final type. So search forward is kind of like a... yeah, see, it just basically generates all the programs that run, and then it execs them, and then it checks to see if it actually produced the right thing. We actually have to do one more thing here. This is actually wrong. So otherwise it's just an okay program, right? Because that can actually produce things that are wrong, but whatever, doesn't matter. But you see how much faster backwards search is than forward search. Okay, we don't talk about things like TMUX and GNU screen, right? Have you ever seen me talk about something stupid like that? It doesn't matter. Stop asking. They're all the same shit. All right, guys. All right. Look at how slow forward search is, and look at how fast backward search is. So forward search starts at the beginning of the program. Backward search takes like the desired output of the program and works backwards. Boom. And the reason you can search so easily in this language is because the language is really simple. Now, unfortunately, this broke. Right? Because this isn't actually the right formula, because when I run it, it runs into a problem. And the problem is that AXMP, which we can go over here and look at, has what's called essential hypotheses here. These. So I don't really know why they're put in the same. No, forward's not general. It's literally, do you start with the outputs and work backwards, or do you start with nothing and work forwards? Right? I feel like what I'm doing is a lot more akin to backward search. But yeah, so this doesn't actually work right now. This program works. But if I want to search for that same equation, so WFF just means that the formula matches the type. Haha, okay, here it comes. What are you guys talking about? Do we need to go to subscriber only talk? But yeah. So this just means that it's a formula that can be expressed in the grammar of the language, right? Think of WFF kind of like, yeah, like does this program parse, right? And then turnstile, I think it's called turnstile. I looked this up yesterday. Turnstile math, yeah. Yeah. T yields, proves, satisfies. It checks to make sure the equation is actually right. Does MetaMath have classic inference rules? So MetaMath has very few rules. You can read the MetaMath guide, basically describes it. But so this isn't like MetaMath as in like, this is the whole MetaMath compiler right here. My whole MetaMath compiler is under 500 lines. And this is the grammar for that MetaMath compiler. So it's a really simple language that involves like a bunch of substitution rules and stuff. So the axioms that I'm working with are specified in here. They build it from almost nothing. So they start with the axioms of propositional logic. Then they have axioms of like some like predicate calculus or predicate logic. And that was kind of confusing to me, maybe just because I don't know that. Like propositional logic's really straightforward. But and then they have the axiom of Peano arithmetic right here. We tried all stream yesterday to prove that 0 was not equal to 1. And I was trying to do it by hand. Like you can read my proof. And oh, it's so terrible and long. Like you have to do all of these intermediate things. But if we can make the computer find the proof for us, then we're rich. Puff and Fresh, thanks for subscribing. Can the compiler do sized vectors? No, it's not. You're a comp sci student. Is it bad that you literally have no idea what I'm doing? Well, so you know what like programming is, right? So MetaMath is a language that it's a stack machine based language. So forward search and backward search with enough randomization shouldn't be very different. So there's no MetaMath is completely constructive. So there's no like you see, this is, I mean, maybe this is the kind of stuff where I just don't have enough formal theory to really talk about it. My axioms might not be constructive. I don't know. All I know is backward search is mad fast and forward search is mad slow. Although that might just be because I wrote the forward searcher crappy and I wrote the backward searcher better. But let's fix the bug in my backward searcher. So right now, the reason that this is getting me some crap with modus ponens is because it's not taking into account these essential hypotheses. But I should just be able to produce them directly because phi and psi should already have the variable substitutions by then. So let's just go to my... So a few things. When we search in here, if x dot, some stupid name. I don't know why they're both called hypotheses, even though they're used completely differently. If x sub floating, because we can't actually use essential hypotheses. Or maybe we can and I don't. Yeah, modus ponens is, it could be the order of explanations of the axioms. Yeah, I think it's that. You can read my code. I wrote a really crappy forward search. I mean, the forward search just produces every possible string in the language, and then like, it's basically brute force program search. It uses the executor in the loop. Yeah, modus ponens is function application, but in order for you to apply the function, I mean, in order for psi to be true, like, because otherwise, without these essential hypotheses, and effectively what it's doing is, if you remove these and you just have that as an axiom, that just says that you can make any formula true, right? Like you know, there's another thing called bottom in logic. I don't know what that means. False. Oh, yeah. So if you turn this sideways, if you turn the turnstile, which is true, And then like this, you get bottom. I get it. That's funny. All right. Yeah, but if I have modus ponens without any of the output stuff, it's just turning, this is a well-formed formula for this. And if it can turn any well-formed formula into that type, then it's broken. So we gotta fix that. Yeah, the problem here is this. Check for essential hypothesis in scope. This isn't exactly right either. Asserts have their own scope, so we can use it. For H in X scope. Suppose is a dictionary. Yeah, bottom and false aren't equivalent. I mean, I know there's like, yeah, different, like false can just be a type in and of itself. What's your off-topic question? Only because you're a Prime subscriber will I entertain. Yeah. If KK sub floating equals false, check essential. Let's just see if this fixes it. Wait, what? How did that just fix it? I didn't even change anything. There's no way that just fixed it. Somehow it just fixed it because I fixed the scope thing? That's crazy. Yeah, so you see it's trying to check the essential hypotheses here for yeah, so we just want to bind to them. We should have, like, we already have these things. So we just want to do the binding. Weird. Alright, let's see if we can find something else that breaks it. I mean, theoretically, we should be able to put anything in, and either search should not terminate, because we can't guarantee that it terminates, or it should produce the thing that it was put in, right? Because, like, we have the program runner, and then we have the program searcher. These things seem to all work. All right, let's try for something harder. Can we get this? That fails. But yet here it seems like I have a proof of it. Shouldn't fail ever. It should continue to search. It should just not terminate. Oh no. Yeah, I should write some tests. That's a good point. These should all be valid tests. And now, if the test passes, for T in tests, search MS tokenize. You've got to tokenize the tests. And math symbols. So search is what will find the program. So we'll say prog equals search, and then we'll exec metamath in the global scope program. We'll say the stack equals that, and then we'll say T equals stack.pop. Assert. Length of stack is 0. Assert ms equals well, ms sub 0 equals t sub 0, and then ms sub 1 colon equals. How do I get Python terminal colors? Tests are only good if they show up in green. If and Colorama. Term color seems better. Yeah. I won't play. And yeah, we'll do. Wait, what? Oh, I used T twice. Don't do that. There you go. All right, now we have some tests. Now let's just add more tests until it breaks. Let's find the minimum test example that breaks. Log.debug. Here we go. Does he ever read subs? What's a sub? Yeah, I read you. My Discord's not become AI Discord, okay? That's like, you know, I don't have a Discord. I think Discords are, for the most part, toxic cesspools. It's like IRC, but easier. The last thing you want to do is make IRC easier. The beauty of IRC was that it kind of was hard to get to get onto. Why do I don't give a shit about Hackintoshing. Don't be poor, buy a Mac. That seems like the kind of thing that you'll spend a lot of time on and not get much return. Okay, now, in order to really do tests, we have to make ones that fail as well. Yeah, okay, that seems right. I mean, we shouldn't be able to prove... Well, I guess I don't really care if it terminates. Yeah, I mean, I agree. Hacky hacks, that is the true... problem with the internet. Don't be poor, classic Ben Shapiro. Is that who I stole it from? Alright, let's write some harder things now. Well, that looks really hard. It should be able to at least find the axiom, right? Oh, and actually, we should also print LP prog is made by. Right. And this is the beauty of doing program search. It's really easy to tell if your program search succeeded. Shouldn't write is made by. Let's make it a color because we can. Let me just clean this up a little bit. I don't even know if failed works because none of my tests fail. Bro, I did one Unity stream. Did one. White's not the color I want. What color should I use? Yellow? Use yellow? Yeah, looks nice. Oh, it's starting to look like a real program, you know? Yeah, and a few terminal colors and things look like a real program, right? So this is the output of the program, and this is the program that that produces it. Yeah, so see, that's just Piano Arithmetic Axiom 1. Right? Look, it knows. It's so smart. Okay. We should actually write the code to check essential. Well, for now, we just really have to say good equals false here. right, so we know this is a producible string. So this should work. But this one doesn't. If prog is none, pass equals false. Else. I'll just put that in LP. There you go. Look, we're failing a test now. It says failed. Python's so fast. What do you mean? We got tests. Actually, I guess, part of the problem is this one actually needs to use modus ponens, which has essential hypotheses. I'm not sure why, like, I kind of liked the bug before. I don't really understand what fixed it. Like, without that, modus ponens should actually be able to produce any string. Whose statement is that? Yeah, Bill Gates invented the software license. That's how he became the richest man in the world. The software license was absolute scumbaggery. But, like, I don't know, man. The new people might be worse. Bill Gates overall was an alright guy. You know, compare Bill Gates, who actually did, you know, produce a lot of value, to, like, the Sundar Pichai type. Right? Like, you know, Bill Gates at least appreciated technology. Sundar Pichai, look what he's doing to Google. It's sad. Amazon's alright. Can you show your no script settings? Why do you care? Why do you care about dumb crap like that? Alright. Variables in scope. So I'm searching in the essentials. Yeah. Maybe that's what changed? Yeah, Yeah, so what happened... Alright, I see why it's failing now. What? Okay, that's fine. I see why it's failing now. And what happened is... basically, in order to use AXMP, you have to bind something to phi, and nothing is bound to phi. So that's why that search doesn't work, because of modus ponens. Let me try to find some things that don't require modus ponens. But a lot of these things do. Oh, and int2 requires disjoint things. I don't even know how to start with that. So first off, we can put this in. Oh, see, look, now it succeeds because it just uses, it cheats and uses int1. That's cute. Yeah. So I guess the binds, I guess we do need to be able to pass in binds to can produce. Huh? Now many things fail. Why? I'm not even gonna go into that. I don't understand. Okay, so we have to check for essential hypotheses up here before we check the variables. And that will effectively allow things to be bound. No, I think we really need to search for them. How, boss, can you hack Red Dead Redemption? No, you get a timeout. Yeah, chat's being low quality. Who's gonna be the first subscriber who gets banned? That's gonna be a day. I googled a little bit what happens. I mean, like, you pay me money, but that doesn't exempt you from a ban. I don't know, man. Does Twitch give you your money back if I ban you? Do I lose money if I ban you? It's worth it, because we'll do it. Some things you have to value more than money, and that's banning people you don't like. Well, that's even more. That's a savage, man. If you get banned and you don't get your money back, that's the most savage shit I've ever heard. Just like stealing. That's how savage it is, but we'll do it because that's what this channel is. We're savage, man. Okay. No, I mean, I guess no, we don't need to do that stuff with binds. Checking essential is really just search or... No, they have to mean the same thing. The essential stuff is computed in the same scope. We can just, here's the code that actually computes it. That's in decompress proof. Oh, wait, what? I put the essentials somewhere else? Oh, okay. Type, MS, and label. I forgot that I did that. I'm not exactly sure why. Yeah. So I guess fee we can bind to whatever we want. This is where it gets a little tricky. Is this where the search gets hard because of these statements? We should be able to produce like the craziest well-formed strings at least. Like this. We should be able to produce this, right? Yeah. Look at that. Look at the length of that string. Boom. It's a nice size string. Can we produce even crazier stuff? I don't even know what's crazier than that. Oh, well, that's just not being produced because it's the wrong type. Wow. This search is so powerful. I remember when you used to have to write this shit out by hand. I don't know. I mean, maybe now we can just like take what we have and go back to a like it's a tactic, right? We can use this as a tactic. We've written a tactic for MetaMath. Oh, all that stuff was so painful. So right now, like this, like tactics aren't going to work at all times, but that's really what it is. Sub will have emotes. I don't know what emotes are, so no. How about this? Here's my deal. I applied to be a Twitch partner yesterday. If Twitch makes me a partner, I'll add emotes. If Twitch doesn't make me a partner, then no emotes. That's right. Twitch, if you've heard me, if you're watching my stream, if you're judging my stream to see if it's Christian channel, I promise you it's Christian channel. Okay. Now we're in 2 plus 2 land. Let's try. This one I'm putting in as an axiom. Is there any way that my searcher is just going to get it? Oh, well. It's cheating and using the axiom. bring the REPL up. What happens if I search for this? Oh, search failed. Do I need to use modus ponens for it? I probably do. No, I need to use the fee. Let's see if we can search for this one. No. Is it a well-formed formula at least? Oh, that works. At least I can make well-formed formulas. I can't prove things because that involves essential hypotheses. What's the Git link? It's at GeoHot Twitchcock. Okay, I mean, should we tackle the essential hypothesis problem? But think about it. When we're done with this, we won't even have to write code ourselves. We'll just be able to... What's the tag system? Yeah, this is pretty similar to this. Can you commit to my GitHub? Well, you can fork and do a pull request. It'd be nice if we can solve for this one. Seems like a lot. Well, let's break it down, right? So MP is the last thing that happens. Implies phi psi should be the next thing that happens. That's phi. Then binop implies so these things are just hard to parse even by hand. That's match? No. That's phi, that's psi. We don't talk about work on here. So that's min. Yeah, okay, cool. So that's phi, that's psi, that's min, and that's match. See? No, so this isn't... All right, let's get to how we can search for that one. Because I think that one gets into where this is going to be, hard. If we could figure out how to search for that... Yeah, but that's all... Yeah, that's really all the trickiness, right? All right, so what we could do now is we could make a new syntax around MetaMath. Like, we can add some stuff to the syntax of this language such that this stuff is more usable to write. Like, basically, what we want to say is something like, yeah, like phi this, right? And then psi this. And then we say x and p. Olibot. Well, the beauty of this system is that you don't have to write much around it. One of the annoying things is MetaMath doesn't actually allow any symbols to be used. Well, I guess we could have like a... like that. I don't think anything used $B yet, did it? There's all the... Here we go. This, we could use like $B, which is like bind. That's not even useful. Like, we're gonna write tactic. This is basically what tactics are in Coq. Because this one fails unless I could satisfy those essential hypotheses. But like simple things like this should work. We should be able to automatically prove that like the successor to 0 is equivalent to the successor to 0. Let's look at the axioms and see what else we can prove. We should be able to prove... It's hard to do much with implies without modus ponens. Definitely prove things like implies equals xy, equals successor x successor y. That should work. Cool. Like, look at how good that is. It's just like this that fails. As a literally by hand ordered logic programming with only left implication and broken substitution. I mean, yeah, that sounds about right. But it's so simple. MetaMath's so simple. Boom. Yeah, essential hypotheses don't work. What else do we want to prove? What else do we want to search for automatically? See, that's basically just application of the axiom schema. But like theoretically, we should be able to find that, but that's up. Yeah, that fails. Oh, well, that's just dumb. Doesn't even parse, yeah. Yeah, like that should pass. Because it is a true statement. But I guess it can't find it. I mean, this should pass. Takes a long time, but it passes. Oh, wait, what? I did it again. Put the commas in, bro. Yeah, okay, that passes. See, now it should be able to take these two things and like apply the axiom schema to get that one, but it doesn't. All right. First off, is that actually? Are we sure that that's true? If I have this as a true statement and this is a true statement, if x equals y implies successor x equals successor y, if x implies y and y implies z, then x implies z. Is that a true statement? Substructural logic programming. Yeah, I mean, these are just tactics. Focusing. I'm confused. I don't really get it. Yeah, but Good. I mean, now we're getting as to why it's hard. I mean, this would be the dream, right? Imagine we could just use it to prove that 1's not equal to 0. Of course, that one fails. But we can show that it's a well-formed formula, at least. Yo, you think we can have it prove 2 plus 2 equals 4? We can write it at least. Plus 2 equals 4. What if it just trolls me and proves it? No, it didn't prove it. Oh. That'd be amazing. But at least is it well-formed formula? It is a well-formed formula. And it does find that. Oh, the dream. If we could just say prove 2 plus 2 equals 4 and it could do it. Oh, that'd be the dream. That'd be the dream, but I think that's hard. We did prove that 2 plus 2 equals 4 is well formed. But unfortunately, 2 plus 2 equals 3 is also a well-formed formula. So there's that. Bro, we're the new age Bertrand Russell. We're Bertrand Russell if we had a computer. You see, Bertrand Russell might be smarter than me, but I have a computer. Yeah. Who's the person behind me? Is there a person? No, there's not. It's a SWAT team, bros. Can you prove things with emoji? I'm done with this emoji shit, but I'm pretty happy with this. Many test. We'll have to get to, this one should be doable. Well, maybe we could work on an easy modus ponens thing. We could add easy test. Someday, man. Someday we're just gonna write in Fermat's last theorem right there, and it's gonna find it for me. At least, you know, when it fails, it knows that it failed too. That's pretty good. I don't even know how to encode the Riemann hypothesis. I read a whole book on it, and I was still confused. One day, though. One day. Delete that comment. Let's try an easy application of modus ponens. What's easy? That one's pretty easy. See if I can use something that's supposed to discover equality symmetry as the well, so we can let me try this. We can say something like, this should just work, implies x equals y, y equals x. That just works. Yeah, that works. Now we want to go like one further. Does this work? It just works. This should be a true statement, right? Well, that's just gonna work too. It's all the same crap. Never mind, those aren't interesting. We want to use that as match for something. Yeah, the point guard conjecture doesn't make sense to me either. Okay, so I mean, this should be a discoverable statement, right? So if I have x equals y and y equals z, then x equals z, and this should work. And now what should also be true, and this is going to involve slightly more proving, is if I switch around z and y there, and that's what's going to fail. Yeah. We could try to prove that one by hand and see what it actually takes. I mean, yeah, maybe this is the simplest one to understand. I don't know. We'd have to write that proof by hand. But I'm not writing any more proofs by hand. We did that yesterday. Few more tests. I'm happy. We had some progress. This is some redemption. This one's good. Hopefully you guys understood this one a little bit better than yesterday's. Yesterday was mostly me staring at the screen. We gotta go to work. It's almost 9 o'clock. We gotta shower. We just woke up. All we did today was wake up and get coffee. I was gonna go get an acai bowl. That sounds kind of nice. I like acai bowls. All I ate yesterday, you know what I made after the stream, guys? I made chicken fingers and waffle fries. That's what I ate yesterday. But I'm going to think about this, and we're going to think about how to get it to prove more complex statements. I guess, like, yeah, what's true about these statements is none of these really, like, they all build up, right? I think it's related to this kind of thing. We're only doing it with, like, one kind of polarity of connectives, right? If it used essential hypotheses, it would consume from the stack. And seeing as it doesn't consume from the stack, when are you going to stream something cool like how to jailbreak the iPhone? Time out! We do math. And if you don't like math, get the fuck out of my channel. That's right. That's right. Good morning, everybody. Today was a good morning. All right. Any other questions before we're done? Everyone have a blessed day. Happy Veterans Day, everybody. Honor the veterans who died for your freedom, and make sure to keep freedom alive in your hearts. That's the thing about America. The freedom is alive everywhere. I don't even think you can kill it. The freedom gets distributed through information. Even if there's this guy PM'd me. Oh, you know what he PM'd me? He PM'd me, fuck you, dude. And you know what I say? Fuck you, dude. That's right. But here's the difference between me and you. You see, I drag you over to this screen. You PM me. Yeah, that's the difference. I don't really understand that. That didn't make that much sense. But it has something to do with freedom, and I love freedom, and this is America. Ah, beautiful morning. Beautiful morning, guys. Beautiful. Oh, he said something else. You know what? We're not going to share what he said. It wasn't that great. It was not that great. It's not worthy of my Twitch stream. That's all. You know what, bro? You start a Twitch stream, and then you can block people. And that's the beauty of having a Twitch stream, you know? You can have that little bit of power over your small domain. But really, it's about delivering the highest quality content. If you didn't want your content to... Wait, what? Oh, here... Get Emacs, dude. Oh, to disable whispers? Yeah, we'll just, if they continue to piss me off, we can disable. Oh, you want to see a proof of... I could probably get that proof in cock pretty quickly. Should we see what AK Spirits has to say? Should we see? Heart. All right, that's nice. Can I prove the square root of 2 is greater than 1? I don't know. What's the high brown stuff today? I don't know what that means. Oh, let's see what Satana 7 said. Should we see? All right. I'm just, that message can just, I'm just gonna, that is just gonna stay there. I don't like anything I say. Big Brain Dota, let's see what Big Brain Dota has to say. I think you got your ASCII a little bit wrong, but hopefully that wasn't an offensive symbol, because we don't support offensive symbols on our Twitch. You already got to talk. You don't get to talk. We're not going to click on that. Hydras aren't offensive. That's right. We don't support offensive stuff in the stream. Offensive stuff gets banned. Atlantis. That's like the people who comment first comment. Wait, guys, it's not against the terms of service to reveal your revenue. You guys were trolling me. There's like a term for when your Twitch chat trolls you. You're going to give a presentation about AI in cars. That's great, but we don't talk about AI in cars here. Whisper review. Meme review. Luai. Okay, we're going to check this one off stream. We don't want to violate the terms of service. Oh yeah, no, see, look at that. That's nice. We could do that. We could share things like that. The cloud's beautiful. Super epic Ben. I'm concerned about this one. Should we click it? Oh, Lithuania. That's a nice place. All right, cool. I don't know. Let's look up Lithuania. Is it a nice place? Very high human development index. It seems like a pretty nice place. They use euros over there. I've never been to Lithuania. I've never made it to that part of the world. I want to go there. Non-trivial. No. We're done with this game. Let's just look up Belgium. My country is a joke. I've been to Belgium, bro. Now we're done with the whisper game. Sorry for late whispers. Look up Portugal. Oh, I went to Portugal once. I have my thoughts on Portugal. Can I understand this math? No, because it's not in English. For real. What I visit in Belgium, I visited a statue of a little boy taking a piss. I went to some museum, walked around some thing. I've been there twice, actually. Yeah, I've been to Lisbon. No, I went to Lisbon. I went to Lisbon for Web Summit. And to be fair, all right, no, so I'll tell you really what drove me crazy. Like, it was like 10 p.m. I was trying to get dinner. There was nowhere open to get dinner at 10 p.m. I was like downtown in a major city and I couldn't get dinner. Even McDonald's was closed. So then I went to the casino and they yelled at me for wearing a hat. And that was my Portugal experience. I also got yelled at in the airport, so I did not have a good time in Portugal. I'm just saying, if you have a choice of countries to go to, no offense, bros, but don't make it Portugal. Yeah. Oh, I love the UK. You know where I went in the UK that I really liked? I went up to Newcastle. I really liked Newcastle. There's this awesome private library there, but you can go into it. I stayed at this hotel right by the train station. It's just very nice. No, Newcastle's like North UK. It was there. It was nice. Yes, I know. It was weird as fuck, and that's what Portugal was. Oh, I love the Netherlands. I love the Netherlands. Great times there. You know, here's what I really have to say about the Netherlands. The food there is so good. I got I think it was toast with berries, and the berries tasted they were amazing. They tasted so fresh. I've never been to Peru. I've been to Czech Republic. I was only there. I was there with this girl, and we were arguing about bullshit, so that kind of maybe taints. But I wouldn't judge Czech Republic based on that. You guys know I love Japan. I've been to Russia. Everything was difficult. You know, the jokes about Russian bureaucracy are all real. I have never been to Pakistan. I really I've spent a lot of time in China, and you see really what lies a lot of the U.S. propaganda about China is. So I am curious to go to the Middle East, but I'm almost too afraid to. I don't know. I really don't know much about it. I've been to Mexico. Everyone's been to Mexico. Dubai is safe, absolutely, yeah. But never been to India. My friend said I would hate India. Switzerland was insanely overpriced, and I tried to buy a draft beer, and it's like these people never heard of draft beer, but I heard I'd like Switzerland otherwise. I have been to the Azores. It was boring. Somalia, no. We got to draw the line somewhere. I loved Vietnam. Absolutely great. Thailand, I feel Thailand is kind of played out now. I got recognized in Thailand, and this upset me. Swat Valley, Pakistan. No, I don't think it is war and stuff. Again, I'm not falling for the U.S. propaganda on the Middle East if I don't fall for it on China. Yeah, I bet it's beautiful. Of course, I've been to Germany, guys. I spent most of my time in Germany and Berlin. Looks like typical Southeast Asia. Oh yeah, Venezuela. Venezuela, I do believe the American propaganda on. I think no way. Communism is bad. Come to Taiwan, the home of semiconductors. It's funny that you advertise it that way. So first off, I loved my time in Taiwan. And Taiwan, that's how it was described to me. Like someone drew a diagram of Taiwan and they said, all right, so up here in Taipei, we designed the chips. And then here's where TSMC is. And then here's where the companies that make the machines are. And here's where the companies that extract the silicon are. Taiwan is a vertically integrated country. I thought that was really cool. I've never been to Jordan. No, I met really nice people in Taiwan too. I think that's you have enough. China's a little harder to get into and to meet people. Taiwan was easier. How about you stop running your mouth and start doing cool hacker shit? Get the fuck out of my channel. All right. I would go to North Korea. I would go to North Korea. I would. Gotta go just chatting to get that partner. Yeah, no, I'm gonna be when I'm a Twitch partner, guys, I'm gonna really step up my game. You know, and I would step up my game on Instagram. I just want to say to all of you that I'm boycotting Instagram because they haven't given me my check mark. Colombia, I've never been to Colombia. One of my dreams in life is to cross the Darien Gap by overland. Though it's like one of those dreams that I'm only gonna do after I have a backup copy somewhere. I hung out at Cambridge a bit. I liked Cambridge. I have been to Hungary. I've been to both Buda and Pest. No. This is why Google changed it. It used to be when you zoomed out that the map stayed flat, but now it becomes a globe because Google wants to counter the flat Earth propaganda. Go to Lithuania. I do. I want to go to Lithuania. I want to make my way down these. I've never been to any of these countries. I've never even been to Poland. The furthest, like it's crazy. Like I've stopped here every time. I stop in Berlin and then I take the train or the plane back. I have done a trip through here. I went to Bratislava just because it was memed in Eurotrip. It's actually very nice. No, I've never been to Morocco. I've never been anywhere in Africa. I've been to Italy. It was hot. St. Petersburg's nice. Warsaw's nice. I bet these are nice. No, I've never been to Romania. Where is Romania? I should know. It's like around here. Oh, Romania, right here. Wow, it's huge. The only thing I know about Moldova is Diane went there and BoJack Horseman. I mean, I really like. I don't know. I went to Serbia. I went to Belgrade. Germans do make nice cars. The Germans definitely make nice cars. I do like second world countries. I think second world countries are where all the cool stuff's happening. Third world countries are like shitholes. Sorry. And first world countries are like, complacent. Whoa, wait, Kerr's actually coming out with a product? I met the founder of Kerr. She's cool. She knows a lot about optics. Wow. Wait. Well, they're doing it. I really hope they come out with this. Yeah, they're using for the masses. Woo! I don't know why it has the dots in it. No. They're not actually going to get micro LED to work. No, don't do that. Don't do that. You don't need to. I mean, maybe. Look, if they pull this off, it'll be incredible, but they don't actually need to get micro LED to work. There's these like little Sony. Yeah, look, it starts mid-2020. Yeah, apparently Ghost is going to come out with a level 3 add-on kit in 2020 as well. Lol. No, but there's what are these? Sony Micro OLED? Yeah, it's these. See, you don't actually even have to go to micro LED. No one's, look, I don't even think Apple has working micro LED yet, but you can use these things. And you've never seen, they have such incredible brightness. They suffer from a few problems of OLEDs, but yeah. No, they don't even have a pre-order button. This means Whenever they have a request pre-order, it means that it probably isn't going to happen. But well, let's see if there is money. I really do want them to succeed. Like, you know, I want these things to exist a lot, to the point that I almost built them. No, they haven't raised more money according to Crunchbase. Oh, the right person at Cur.tech. That's cool. Apple was going to use micro LED in the Series 5 watch. I mean, I don't know. I haven't seen micro LEDs work yet. Yeah, it suffers from burn in and burn out if you like burn them really hot. So they have the traditional OLED problems. But this is really cool. At least they're going for it. And it's this number. The HoloLens and Magic Leap have absolutely atrocious field of views. I think there's also, I think some guy did end up building the North Stars. So I spoke with this guy. He's cool. I've met him before in Shenzhen. I hope he's selling them. Backordered like crazy. Yeah, come on. Yeah, but these are so good. You know, I have a Project North Star. They're really amazing stuff. They sell them the kit for $299. Oh, I guess, does this include the occipital sensor? Oh, okay. Leap motion controller, occipital structure core not included. Are they selling these? Can I just buy one? Occipital structure core. You know, this is a great deal, and like this guy, you know, if you want to buy something today, if they let you buy it even though it's sold out, he'll build it. He'll send it to you. He's a good guy. Can I just buy these? Or is it contact us? Oh, I actually can buy them. What does this include that this one doesn't? Wait, what is ScanAct Pro? Is this free software? Oh, no, you have to... Pro. All right, so it actually includes the software. It includes a tripod. I've seen these. They're okay. They're using structured light. No, I think you can just add to cart. Oh, it actually doesn't let you. Oh, those are just sold out, but the kit is a back order. Wait. But then I can do the kit plus assembly and calibration. Wait, this is just a scam. For $200 more, I can get it assembled and calibrated and order it now. Or if I'm too lazy to do that, I can buy this one, which is just Kit C for $100 more to punish people who didn't read the website. Oh, no, wait, they are on the cart. Never mind. You can just order them. I'm going to get abandoned cart emails. Alright, guys. Thanks for watching my stream. I think this morning was much better than yesterday. We're not actually going to do a North Star stream. I'm glad to have you all here. I gotta go, guys. I gotta shower. I'm going to work. Write open source software. change the world.